Yes, indeed. Today we have with us constellation of brilliance. To further sanctify this moment, we now invite our student, Sri Joydeep Chatterjee, Shankha Ghosh and Arpun Chatterjee of this university to present a melodious invocation song.
Thank you. To begin this auspicious occasion, we will now proceed with the lighting of the lamp, symbolizing knowledge, enlightenment, and progress.
We request our chief guest, Honorable Vice Chancellor, Sir, special guest, guest of honors, President of SVBBI, and the Chairman and Organizing Secretary to kindly come forward for the ceremonial lamp lighting.
Asato Masadgamaya, Tamosho Majyotirgamaya, Mrityurma Amartam Gamaya. Thank you. Thank you, sir. To officially welcome the August gathering, I invite Dr. Shubhashish Bhattupal, the tireless organizing secretary of SVBBI Con 2020, to deliver the welcome address.
Good morning to all of you. Suprabhat. On the behalf of organizing committee, I welcome you all the dignitaries on the dais, all the respected guests, all the delegates and other dignitaries who are here in the inaugural function. On the dais, Professor Dhubajyoti Chattopadhyay, eminent biochemist and biotechnologist of India and world. I welcome you, sir. You are accepting our request as chief guest of today's function. Professor Tirtha Kumar Datta, Honorable Vice Chancellor of our university, who is also chief patron. In spite of his busy schedule, he has given the module and has fixed this date and given permission for conducting this 9th SVBBI con. And this is also, we are celebrating 25 years of Veterinary Biochemistry department, which was separated in the year 2000 as per VCI syllabus under the leadership of the then Vice Chancellor, Dr. Ashwin Kumar Bhattacharya sir. So, on the behalf of this organizing committee, I welcome you, sir. Our special guest, Dr. Tuen, Director, Institute of Public Health, Germany, Leipzig University. So, I welcome you, sir. In spite of your busy schedule in India for a few days, so you have given time for us to remain present as special guest in our inaugural function. We welcome Dr. Mihir Kumar Sarkar, Director ICAR NRC on YAC. In spite of his busy schedule, he has given us time to remain present as guest of honor. We welcome you, sir. I welcome to Sri Devol Rai sir, Principal Secretary, IFS. In spite of his busy schedule, he has given me yes, I will remain there at the inaugural session. Because our theme is like that, from farm to forest. We are involving here the theme with the farm animals. The experts are here from farm animals. Our Vice Chancellor, Dr. Datta, is geneticist and as well as animal biotechnologist. Dr. Mihir Sarkar is the field of physiology. Dhubajyoti sir, Mohanty sir, they are renowned biochemists. Mohanty sir is having exposure with some aqua animals also. So this year we are thinking about that our conference will be involved farm animal to forest via companion, poultry and other livestock sectors including the aqua animals. So on the behalf of welcome our organizing committee, I welcome you Devon Lai sir for your nice presence here. Our registrar, Professor Partho Das, the dynamic one, so has given all sorts of help. So we, on the behalf of organizing committee, I welcome you, sir, as you are present here as guest of honor. Our president, Dr. B.P. Mohanty, president of SVBBI. He was ADG, he was renowned biochemist and biotechnologist in various institutes of ICR as well as SVB. So on the behalf of organizing committee, I welcome you, sir, and we are also given acknowledgement. You have given us this opportunity to conduct this conference here at Kolkata, the city of joy. I welcome our chairman of this organizing committee and Dean Veterinary Faculty, Professor Nirotpal Ghosh sir. So he is also instrumental, he's trying to make our conferences very fruitful. On the behalf of organizing committee, I welcome you, sir. Our former Vice Chancellor sir are here, Professor B.B. Mollik sir, Professor Punnendu Biswas sir, Professor Chanchal Guha sir, Professor S.S. Dana sir, expecting Professor C.S. Chakraborty sir also. Professor Tapon Mandal sir will not present due to some health problem. On the behalf of organizing committee, I welcome you, all of you, sir, for your gracious presence here. I welcome all the dignitaries here, our beloved teachers, our respected retired teachers also, and all the scientists throughout the India and world who are present here as delegates, as guests, as invited speakers from ICAR NDRI, from ICAR IVRI, from all the leading institutes, SUs, IIT, IISER, NISA, and from Germany. Thank you, sir. Dr. Ahmed is here from German University. Dr. Professor Nitali Chatterjee will be coming for third time. So I welcome you, ma'am. And our BCI President, our West Bengal Veterinary Council Chapter, Dr. Ashutosh Vishwas, Dr. Gurucharan Datta, Veterinary Council of India member, and our EC member also for universities. Here present, Dr. Sohini De, Joint Director, Edgar IVRI, Dr. Madan, HOD, Animal Biotechnology Division, IVRI, Dr. Sunil Anteru, HOD, Division of Animal Biotechnology, NDRI, Dr. Rakesh Kumar, our Professor Dr. Satya Sharma, Dr. P.C. Behera, Dr. Bhure, and all other greatest biochemists of the world. Our Dean Fishery Faculty, Professor Nagesh, our Dean Dairy Faculty, Professor Bach, our DSW, Dr. Pankaj Kumar Vishwas, our medical officer also, Dr. Kulabi, and all the personalities related to biochemistry and biotechnology. Our registered West Bengal Veterinary Council, Dr. Subramanda Mohanty, Dr. Arnav Sen, HOD, Principal Scientist here at IVERA ERS, Dr. Santanu Boni, HOD and Principal Scientist, NDRI ERS, Kollani, and all the dignitaries who are present, our National Professor, Dr. Sachinandan De, and Professor Sumit Kumar Nandi, ICI National Professor, Professor Emeritus, Dr. Sitanshu Mohan De, all the dignitaries on the behalf of Organizing Committee, SVBBI Con, I welcome you all. We are having so many sessions, including plenary session, some academic intervention meet, poster sessions. So all the experts, near about 50 invited lead speakers will deliver their lectures. Some scientists, teachers will deliver their oral presentation, some will be involved in poster also. All the students who are participating in our conference, I welcome you all. Actually, due to paucity of time, we are not included for their oral presentation, so we have to give some poster presentation also. All the awardees, our retired teachers are here, our respected teachers from Department of Veterinary Biochemistry, Department of Physiology, Professor Dalin Kumar Nandi, Professor Soibal Chattopadhyay, Professor Sagar Sennam, and all the other dignitaries are present here. Once again, I, on the behalf of Organizing Committee, I welcome you all. Our biochemistry department under Veterinary Council of India, in most of the colleges are separate department. Again in 2023, in some colleges they are merging with physiology, but different deliberation with Veterinary Council of India's meeting, we are fighting, and they have included our veterinary biochemistry as a separate department in the next year. When it will come through DHD, it is in the draft module. So each and every colleges there will be separate veterinary biochemistry and separate veterinary physiology, separate veterinary biotechnology departments. Again in PG, regulations also besides drafting, I think within few months it will come in final form. So we are thankful to President Veterinary Council of India, as well as all the members of Veterinary Council of India, for supporting us for all the colleges for separate veterinary biochemistry, separate veterinary physiology, and separate veterinary biochemistry departments. With our respected, the blessings of our respected teacher, Dr. Alien Singh, late Dr. Alien Singh, and IVRI, we had started our journey. So, in this day, we are to pay our homage or respect to all the renowned professors in the field of veterinary biochemistry and biotechnology for their contribution. Professor Alien Singh, Professor S.P. Ghosh, Professor Murthy, Professor Srivastav, and all other Professor Ganguly, all the renowned biochemists and biotechnologists. So, in these 2 days, all will be enjoyed in scientific gathering, along with delicious foods of Bengali and related food. Also, we are maintaining some other food also, South Indian and others like that. And cultural evening in the river cruise. I think you are staying comfortable. So, anything their problem, so we should maintain, we will try to maintain, to overcome that problem. So I wish, if you will help, you will cooperate, and you will enjoy, so we will make our 9th SVBBI crown a grand success. So thank you very much for here. So thank you once again.
Thank you so much, sir, for your warm and inspirational welcome. Now we request the guiding pillar of SVBBI, Professor B.P. Mohanty, President SVBBI, to present his address and highlight the activities of the society.
Namaskar. Very warm welcome to all of you. Respected dignitaries and guys, distinguished guests, esteemed colleagues, fellows and members of the society, young scholars, dear friends, and everybody attending the program, online and offline. On behalf of the Society of Veterinary Biochemists and Biotechnologists of India, on my own behalf, and on behalf of our organizing team, I extend it is my proud privilege to extend you a warm welcome to this August gathering and the 9th convention of this group that we are celebrating in the City of Joy. It also coincides with the silver jubilee of the Biochemistry department of this university. It is with immense pride and heartfelt joy that I welcome you all to the 9th convention. This gathering is just not an event, it's a celebration of our collective journey, our shared vision and unwavering commitment to advancing veterinary biochemistry and biotechnology for the betterment of animal health, production and ultimately human well-being. I will talk about our legacy. SVBBI was born, as our secretary mentioned some time back, by the dreams of the pioneering educators and scientists who foresaw need for a national platform to nurture this discipline. From the first meeting at IVRI in 1995 to its formal registration in 2008 and later in 2016 we had the first convention at UUT Bhubaneswar organized by the Department of Veterinary Biochemistry, Faculty of Veterinary Science, Bhubaneswar. For this journey, our people are Torch bearers are Dr. Ilan Singh at Iveri, Dr. More, Dr. Sukumar, Dr. Dr. Aril Prasad, Professor Bhatwell, Professor Bisui, Professor Bera, all of them. We join together, join together to make this society. As we stand on the shoulder of these visionaries, we reaffirm our gratitude to them for laying the foundation of this institute. Our activities during the past decade, this is the 9th convention. We have organized conventions across the length and breadth of the country, started at Bhubaneswar, Bengaluru, Isar, Tirupati, Mathura, Jabalpur, Vijayanagar, and now in Calcutta. Each convention has been a milestone, enriching our discipline with new ideas, collaboration, and strategies. Our society has instituted several awards. As you understand, science when merit is acknowledged and inspiration is shared. So several awards for different categories of scientists or different age group we have instituted to encourage people for recognizing their excellence, honoring the teachers, scientists, and young researchers. While celebrating the contribution of veterans, we have the veteran awards, people reaching age of 65 and above. We honor them for the lifetime contribution with Veterans Award. Coming to this year's theme, it is advancing animal health and production through biochemical and biotechnological innovations. It is both timely and visionary. In the era of One Health, where animal health, human health, and ecosystem health are inseparably linked, biochemistry and biotechnology hold the keys to sustainable solutions. From proteomics to genomics, nutritional biochemistry and diagnostics, our discipline is poised to address challenges of productivity, disease resilience, and food security. This convention will serve as a crucible for ideas where young minds and seasoned experts converge to chart pathways for innovation and its impact. Looking at the future, we have taken many bold steps in outreach programs, launching our official website and biotechnology, which are planning to bring out shortly in a year or so. The journal will be our academic voice, amplifying Indian research to the global space. Looking ahead, we aspire strengthening collaboration across universities, research institutes, and industries, foster mentorship for young scientists, contribute meaningfully to the national policy of animal health and production, and position India as a leader in veterinary biochemistry and biotechnology worldwide. Then call for action. Dear friends and colleagues, science is just not about discovery, it is about responsibility. As biochemists and biotechnologists, we carry the responsibility of ensuring healthier animals, safer food, and a sustainable environment. Let's use this convention as a platform to learn, share, and inspire. Let's take pleased to work together across disciplines and generations to make SVBBI not only a society for professionals, but a movement for national progress and global impact. And above all, for the Viksit Bharat, the call for the Viksit Bharat by 2047. Once again, on behalf of SVBBI, I extend my deepest gratitude to WFS Kolkata for hosting us with warmth and excellence. I thank all delegates, sponsors, and organizers for their tireless efforts. At the end, I would like to, because the galaxy of scientists, experts, they are sitting, and we know many of them, my colleague, Dr. Bhatwell has already mentioned them. We visited in the dais, Professor Dhruv Chattopadhyay sir, and he is a great biochemist and with the Society of Biological Chemists and other many forums he is associated. And he is a leading figure in the field, in the sector, and a big brother to many of the biochemists sitting here. We are really thankful that he found time to be our chief guest and to be here. And all other dignitaries on the dais, I am not taking the name of everybody. but I must mention a few because when we started as students at Ivory, 87, 88, late 80s, Dr. B.B. Malik, the founder and Vice Chancellor of this university, he was at the Joint Director Research. Sir, thank you so much, and it's a great pleasure to see you all. We go back to 1987, 88, and we feel really young when we see people like you, Professor Vishwas, Professor Kansulgo, and all other Vice Chancellors, and my Guruji, Dr. Poritos Joshi, who was my supervisor, and he was a team member of Dr. Malik sir. So he's here. It's a proud privilege to mention you. And we are scientists, and whatever we have achieved, whatever science we have done, because of such great teachers we had and the things they taught us. And my senior colleagues, Dr. Pal, former Joint Director, CIP Mumbai, Dr. Satya Sharma, Dr. Roy, Dr. Tamil Nandi. So several people I am not taking names for all. So thank you all for making yourself present here and encouraging our young scholars, scientists, and young faculty members. And it is a great gathering for the senior colleagues also. So thank you all, and we wish you enjoy the 2 days, contribute to our society, share ideas, and make us grow further. Thank you all.
Thank you very much, sir, for your visionary deliberation.
We would now invite the guest of honor, Professor Partha Das, Register, West Bengal University of Animal and Fishery Sciences, to share a few words.
Namaskar. Very good morning to all of you. Sitting on the dais, Dr. Tirtha Kumar Dutta, Honorable Vice Chancellor of West Bengal University of Animal and Fishery Sciences, Professor Dhrubajyoti Chattopadhyay, Honorable Vice Chancellor of Sister Nivedita University, Professor Truen, Director, Institute of Animal Hygiene and Veterinary Public Health, University of Leipzig, Germany, Dr. Mihir Sarkar, Director, ICR NRC on ER, Sri Deval Roy, Principal Secretary and PCCA, Government of West Bengal, Professor Nilotpal Ghosh, Chairman of the Organizing Committee, Professor Subhashish Bhattacharya, DREF of our university and Organizing Secretary, of the dais, all the formal Vice Chancellor of our universities, Director of different institutes, distinguished delegates who come across India, ladies and gentlemen, and my dear students. At the outset, on behalf of myself and on behalf of my university, I extend heartiest greetings to all of you. Really, it is a proud privilege for me to stand before you and to say something in this august college. Now, subject biochemistry, I still recall my UG days. When the teacher used to teach the biochemistry, some of the figure of the sugar immediately changed by replacing the hydroxy. Just he's changing very quickly in the blackboard the picture of the diagram of different isomers of the glucose by changing the hydroxyl group. So it was that time it was not understandable by us very quickly, and often we become very much confused. And even then there was a confusion in that time how to identify between L and D glucose, because they are used to be told they are not the mirror image of each other. So that days biochemistry and biochemistry books, somehow they help us to make the subject understand. When we come in the postgraduate studies, PG and PhD, again I'm a man of anatomy, the histochemistry comes to we come across. So while reading the histochemistry, again we have to read rediscover the biochemistry. So definitely that time the books of histochemistry, I can remember the Pierce and Bancroft and the books of Leringen, they helped me a lot to understand the biochemistry. And when I joined as an assistant professor in this university, again the fear psychosis comes to me, my head of the department. First time he told me you have to take the classes on histochemistry for both for PG and PhD students. So from that day I again learned biochemistry and I become fond of this subject. And that time my better half, she helped me a lot to clear some doubts. And I have a close association with this biochemistry department, Professor Botobel. We are working together. I have guided more than 18 MBSc and 5 PhD students. In all the advisory committee, he was a member. And in none of the project, I have not excluded the biochemical parameter. In 2004, I worked on the extrapancreatic sources of insulin, and he himself helped me to identify the foul insulin. So we isolated that and we prepared the antibody and we published a very good paper. And on the basis of that, I got the post fellowship in abroad. So the association with the biochemistry become my passion, and all my research projects have been formulated accordingly. So immense importance of the subject is not to be told, because I am sometimes very much jealous, because he has been included in almost all of the advisory committee member in all the subjects. Even I have seen the extension students took minor or supportive as a biochemistry. So how popular he was and how popular he is and how this subject is expanding day by day. So thank you, Dr. Waterpal, for enriching the biochemistry to our students, and also me also. I get a lot of help from him. Now, I am not the man of biochemistry. I think in this 2 days deliberation, a lot of eminent speakers are there. They will tell much. They will show you the guidance, what is the recent trend of biochemical research and biotechnology. And it is the only branch which actually help to know the molecular level. So we cannot ignore it. We cannot neglect it, and we have to give much more importance on it. So at this end, what I can say, now our research should be in such a way that every research project should be a translational research, so that it can ultimately benefit the animal husbandry of the particular and mankind in general. I am not lengthy my lecture. So again, I am thankful to the organizer for giving me the opportunity to say something before you. And again, my love to the subject biochemistry is still continuing. I hope this conference will be of great success. And our organizing secretary is quite able. He make a very factor program for all of you. I hope you will enjoy Kolkata, enjoy the conference. Thank you very much.
Thank you, sir. Today's chief guest, Professor Dhrubajyoti Chattopadhyay, Honorable Vice Chancellor, Sister Nivedita University, Kolkata, an eminent biochemist and biotechnologist, and also a visionary leader whose contributions to the field are monumental. Sir, you are requested to grace us with your thoughts and formally inaugurate today's convention and the National Symposium. Sir, please.
A very good morning to everybody. Respected teachers, researchers, participants, all of you are actually with my team, a very, very prestigious one. I really want to thank the organizers for giving me these opportunities to be with you in this 9th annual convention of Society of Veterinary Biochemists and Biotechnologists of India. Now, this national symposium, I just came to know that almost around 500 participants from India and abroad are going to be there. There will be a number of research papers which are going to be deliberated, and that makes this whole conference a real successful one with respect to also commemorating this 25th year of the Department of Biochemistry of this university. So I really want to congratulate the university for hosting this particular conference, and definitely to Professor Subhashish Bhattacharya for inviting me to be present over here, along with all the other dignitaries who are present over here, on the dais. I just want to share with you a couple of the things which I just thought that I must mention because the responsibility was given to me by Professor Potopal. Now, you know that while I received this particular invitation, I was thinking about this global transformation. Now, this transformation of the global animal health and production systems over the past few years has been driven extensively by advances in biochemistry and biotechnology. These disciplines, once largely confined to academic laboratories, now shape the everyday realities of livestock management, disease prevention, breeding strategies, and sustainable food production. As the demand for animal-derived products continues to rise, particularly in the developing world, and as environmental pressures intensify, biochemical and biotechnological innovations hold unprecedented significance. So in that background, ninth convention is going to be very, very important. And they not only enhance the productivity, but also contribute to animal welfare, biosecurity, ecological stewardship, and the economic resilience of farm communities. As Professor Botupal and Professor Das is mentioning, that the fundamental and the foundational basis of understanding this biochemistry and that being application into the animal physiology, the metabolism, and the disease processes, these are becoming very, very important in the last few years. Now, at the cellular and molecular level, biochemical research has provided insights into nutrient utilization, the enzyme function, the immune responses, and hormonal regulations. Now, biotechnological advances build upon biochemical understanding to introduce tools that can fundamentally reshape how animals are bred, treated, and monitored. The most transformative development, what actually we could find it out, is the molecular diagnostics, the genetic engineering, the reproductive technologies, and vaccine innovations. Now, collectively, these tools are actually reduce disease burdens, improve production trades, and increase efficiency and sustainability for livestock systems. Now, as Professor Mohanty is also mentioning about the different aspects of this biochemical and biotechnological research, what I could find it out that one of the most important areas what we consider in the last few years is a molecular diagnostics, which is actually drastically shortened the time required to detect the pathogens. The techniques such as polymerase chain reaction, loop-mediated isothermal amplification, and the next generation sequencing allow for rapid and precise identification of infectious agents. And in the field of therapeutics and disease prevention, biotechnology has revolutionized the vaccine development. The traditional vaccines often depend on attenuated or inactivated pathogens, which may involve the lengthy culture process and variable efficacy. The recombinant DNA technology enables the creation of highly targeted vaccines. And what we could find it out, that the adoption of marker vaccines, which allow the differentiation between the infected and vaccinated animals, DFA, has enhanced control programs for disease of great significance. Alongside with the vaccines, the monoclonal antibodies and novel anti-parasitic agents derived through biochemical research represent emerging frontiers for animal therapeutics. And the one of the most another important area what our honorable vice chancellor is also working with is the domain of genetic improvement. The conventional breeding, though successful in enhancing traits like growth rate, milk yield, or egg production is often slow and limited by visible phenotypes. The modern biotechnology provides tools for genomic selection, marker-assisted breeding, and even direct gene editing. Genomic selection harnesses whole genome information to predict breeding values with far greater accuracy than pedigree-based models, enabling rapid improvement of disease resistance, fertility traits, and feed conversion efficiency. The reproductive biotechnology also plays a pivotal role in accelerating the genetic gain and optimizing the herd management. The artificial insemination remains the most widely used technique, allowing for the dissemination of superior genetic material across the global herds. Now, biotechnology also supports the precision livestock farming, the PLF, an emerging discipline that integrates sensors, data analytics, and biochemical monitoring to ensure the optimal animal welfare and productivity. Despite its immense potential, the application of biochemistry and biotechnology in animal systems is not free of concerns. The ethical debates surround gene editing, cloning, and intensive breeding practices, with critics cautioning against unpredictable ecological consequences or undue reduction of genetic diversity. These issues are also very much related to the animal welfare, the biosafety, and the equitable access to technological benefits and needs careful consideration. The regulatory frameworks must therefore balance the innovation with societal expectation, relying on transparent risk assessments and participatory stakeholder engagement. Importantly, the responsible use of the biochemistry and biotechnology must prioritize animal welfare, environmental integrity, and the livelihoods of the smallholder farmers. To end, I just wanted to mention that innovations have fundamentally reshaped the landscape of animal health and production, from the diagnostics to recombinant vaccines to genomic selection, the enzyme supplementation, and precise farming. The technology is enhancing the productivity, and this is driven by population growth, climatic changes, evolving consumer demands, and the continued integration of scientific advances into livestock systems. This is very, very essential right now. The future of animal agriculture lies not merely in increasing output, but in achieving systems that are resilient, ethical, and environmentally responsible. And that there, the biochemists, the biotechnologists, they should deploy it judiciously and offer powerful pathways towards that particular vision. And looking forward to the future scientists who are here, the students specifically who are participating in this convention, that there is a huge responsibility for you to consider this new aspect, what is already mentioned, to have the translational aspects of biochemistry and biotechnology. Thank you. Namaskar.
Thank you so much, sir, for your wonderful words. Now, may I now invite our special guest, Professor Dr. Yu Tuen, Director, Institute of Animal Hygiene and Veterinary Public Health, University of Leipzig, Germany, to address the audience.
Good morning to everybody from Germany. Thank you very much for the nice introduction. And dear Mr. President, dear Honorable Vice Chancellors, Honorable past Vice Chancellors, dear colleagues, dear students, ladies and gentlemen, I'm very honored by the privilege to deliver a short inaugural address on occasion of the 9th annual convention of the Society of Veterinary Biochemists and Biotechnologists, and the National Symposium on Advancing Animal Health and Production through Biochemical and Biotechnological Innovations, organized by the Department of Veterinary Biochemistry of the National University of Animal and Fishery Sciences and the Society of Veterinary Biochemists and Biotechnologists of India. This is a very long phrase, but I think our world faces challenges that cannot be segmented into closed boxes. They are all fluid, interconnected, and unfortunately very urgent. This recognition brings us directly to the first major theme of my brief address, the One Health approach. There is no human health without animal health, and there's no animal health without human health. And there's neither human nor animal health without an intact environment. These are not separate entities. We have seen time and again that, for example, zoonotic spillover events, ecological degradation, or climate change will ripple across all domains, threatening, and it's very obvious in this crazy times, global stability. Embracing One Health requires true multidisciplinary collaboration, recognizing that every discovery made in one field has implications for the others. This interconnected perspective must inform our second, equally critical mandate, the necessity of research for impact. It is not enough for a discovery to be novel. It must also be actionable. Our laboratories and academic facilities are producing brilliant findings, but the true measure of success lies in the impact of that work on communities, clinics, conservation efforts, and on our society. We must ask ourselves at every stage of investigation, how does this research translate into a tool, a therapy, or a solution that serves humanity and the planet and make our life better? A look over the topics of the presentations of this conference clearly reveals that this conference will be a testament to this collaborative spirit. Let us take the opportunity of this Congress to meet and discuss new collaborations to solve some of our biggest problems in the various fields of veterinary medicine. And let us commit to the future where our research does not just seek knowledge, but actively delivers tangible benefit. I wish you all an interesting Congress with many conversations, discussions, and new ideas, new projects, new collaborations, but also time and leisure to enjoy the city of Calcutta with all its beauty. Thank you very much.
Thank you, sir. Thank you very much. You came over here from a long distance and we are enriched by your words. We have with us guest of honors. May I request Dr. Mihish Sarkar, Director, ICAR, National Research Center on Yak, Dirang, Arunachal Pradesh, to record his speech.
Today, we gather to discuss on one of the most critical pillars of global sustainability, that is the nature of diagnostics, animal production and health across all broad spectrum of life diseases that shares our work and the poultry, agriculture, wildlife, and ladies and gentlemen, today's theme is not only timely, but variation point. Recently, our world is now becoming more interconnected. Recently, the health of human beings, animals, and ecosystem are all interconnected. Modern veterinary science is no longer confined to small animal farm. Small animal farms and small clinics because they now control the global food security, public health, biochemical conservations, and most importantly, economic stability. Chief guest of today's function, Professor Petravartan, Honorable Vice Chancellor of this University, Dr. Datta, Professor Kuyen, Guest of Honor Mr. Rai, Dr. Dinapur Ghosh, Dr. Partho Das, President of the Society, Dr. Mohanty, and very dynamic organized secretary of this symposium, Dr. Patakar. Indeed, it is my honor to address this symposium as a guest of honor. Ladies and gentlemen, we now stand at the threshold of technological revolution. Recently, modern tools such PCR, RT-PCR, metagenomics, and whole genome sequencing, they enable faster and accurate disease detection by elective pathogens. Not only detect diseases, but they also predict with certainty the origin, evolution, and the disease migration. Now affordable diagnostic kits are available, which are now transferring the whole veterinary information by detecting diseases, remote farms, fish ponds, and in wildlife in real-time basis. Real-time diagnosis means early intervention. Early intervention saves livestock, livelihood, and ecosystem. Likewise, precision animal farming, which uses sensors, smart collars, automated feeders, and climate control animal chambers, they allow the farmer to detect temperature, nutrition, trace level of the animals, and productivity. And AI and digital epidemiology also play a critical role in this regard. Now AI-driven platforms are available which analyze health data, temperature factors, and migration pattern, and correctly predict the onset of epidemic. So what lies ahead? Ladies and gentlemen, when looking towards future, let's commit to invest more in research and innovation, train new generation scientists and veterinarians, strengthen disease surveillance, promote animal production, protect wildlife, and go for biodiversity conservation. Just remember, animal health is not a sector. Rather, it is a shared responsibility that connects every citizen, every household, every farms, every forest, and almost every nation. So in the last, ladies and gentlemen, I am confident the idea which will be shared in this symposium will ignite new collaboration, new ideas, new determination. Once Charles Darwin said, in the long history of mankind, those who have learned to collaborate and improvise have prevailed. So let's mark today the beginning of genuine collaborations for advancing animal health and reproduction and to build future for all. With this, I conclude. Right.
Thank you so much, sir, for your most valuable words. Now, our renowned guest of honor is Sri Devang Rai, IFS, Principal Secretary and Principal Chief Conservator of Forest and also Head of the Forest Force, West Bengal. I would like to request, sir, say a few words to the gathering.
Good morning. This is the most pleasant time in Kolkata, and I see other than Kolkata, a lot of people from outside outside the state has come, and one renowned scientist from all over the Europe has come here. So I wish they are having a good time over here, and I welcome all of you to my city. Mm. Uh, I am honored to have been invited to this national symposium of the Society of Veterinary Biochemists and Biotechnologists of India. On the dais, there are renowned scientists like Professor Dubojyoti Chattopadhyay, uh, Honorable Vice Chancellor of this university, Professor Tirtha Kumar Datta, and a galaxy of other scientists and academicians. Before me are all the luminaries in this field from all over India. Uh, I am a forester by profession, probably you have understood that from the introduction. And being one of the applied field of the biotechnology and biochemistry, I take an inside view of the developments that are happening in the fundamental field and also its spillover applications to the animal sciences and by extension to the wild animals as well. Uh, in the field of uh, in the field of biotechnology and biochemistry, probably the recent exciting development started when, although it was ever exciting since I was a student, but probably a big boost came when, if I am not wrong, when CRISPR Cas9 tool became available to you, the scientists, and we have started playing the god. Uh, Building new disease resistance, uh, and so many advances that help in specifically identifying, snipping away selected genes and inserting into it gives so much power. But as it is said in the Spider-Man movie, with great power comes great responsibility. So that should be our motto here. That we should use this power very responsibly, as Professor Chattopadhyay has pointed out very nicely. Here, there are very exciting development in your field, and as I said, I am taking an inside view of it, turning an animal into a biofarming agent, getting all sorts of pharmaceuticals from it. The proud Indian scientists have developed SNP chips for the cows, which help us in identifying uh, the, the native breeds of the cows, which have high prospect in conservation and future development of the desirable traits. You are doing semen sorting technology, although I am told it is not yet perfected, but not only in case of not only in case of animal husbandry uses, it also holds great prospect in the wildlife biology as well. The list is endless. Yeah, the application and the power that the modern advances in biochemistry and biotechnology has given to you, and you are really trying to put it into best of the use for the advancement of the mankind and the sector in particular. Uh, in the field of wildlife, certain things are taking shape. I would like to mention just a few. Cryopreservation is one of the things through which we store the DNA material for future use. We use the molecular markers to assess the genetic diversity in a wild population, and this is being used extensively. We use uh, genetic engineering only in extreme cases, like when an animal is in the brink, when a species is in the brink of collapse. For example, chetridiomycosis in case of amphibians, for building resistance against this kind of fungal infection in wild animals of amphibians. We do resort to the genetic engineering, but this is very rare. Illegal food, illegal trafficking of animals is another sector in which molecular biology tools are very widely used. The sample from the illegally traded animal is analyzed for its unique genetic traits, and in this way we find out what is the origin of the specimen and what is the trade route that is followed for the trafficking of the animals. We, in some cases, we use uh, reproductive, we use novel biomarkers, right? MicroRNA, reactive oxygen species, etc. But these applications are very rare. Semen sorting technology has a high prospect in wildlife, although it has not been used. But I will come to it because it has got huge application with more and more contraction of the wildlife habitat and disjunction distribution of the different habitats with little or few interconnections in between. The inbreeding has become a real problem. So, in some cases, probably we are not probably in some cases we are observing the semen which is highly distorted, defective, and not able to impregnate and develop into a good embryo. It is happening in case of Asiatic lion and geese. It is happening hugely in case of cheetah. You know, raw homozygosity in case of cheetah is 95%, isn't it? So this kind of developments, this kind of semen sorting technology and leading to identification of a healthy spermatozoa and impregnating with a healthy ova, leading to development of some healthy individuals in captivity followed by their wild release. This holds the key for the future survival of species which has very high degree of homozygosity. The technology is being developed mainly by the veterinarians, and probably will use it when the time comes. Uh, the speech cannot be complete without what use we are doing in Bengal. Some might be interested in knowing it. So, although the diffusion is the only way through which the technology is developed by you scientists come to the wildlife applications, but we do use it. Biobanking facility has been developed in Darjeeling. The guy who developed over there is seated here. He will probably speak here. We preserve the gas and the somatic tissues for future use in case the species falls into a critical level, and resorting to the paleo DNA or DNA that is preserved this way is
called for. We are using the molecular biology technology, techniques for population estimation in case the estimation is extremely difficult. I will give a live example, first time done in India. Um, the Himalayan black bears, they come in hordes during this winter time, and we had really difficulty in knowing how many are there in the wild and what kind of population I am looking at. So we use the hair coral method. It's practiced in Canada, probably in Europe as well, I am not sure. So here we create a track, a lure which attracts the black bears, composite, a degraded product of blood, honey, and also alcohol, and they come lured by that scent, and in the process they has to go through certain loops while their hairs are pulled away. So the follicle remains, and using that follicle, we try to find out through the polymorphic loci estimation, we try to find out how many unique individuals are there. The technology is still in developing stage, but we did 2 rounds of estimations and we have been able to find a way how many animals are there, and we could develop our management methodologies. Gene flow is a major concern, as I told you, that main habitats are fragmented. If I go back further in the past, you see all the Tarai areas, sub-Himalayan areas were one rhino habitat. Now what you see, there are so many patches of rhino habitats, and these are inbred year after year. So we need to find out whether there is possibility, there is similarity between this and that, what would be the optimal strategy for transferring a male or a female from this population to that. Before that we need to know what kind of variability is there. So we do make this kind of analysis in order to find out what would be the strategy of transferring a male rhino, or more recently female rhino, from say Jaldapara to Gorumora, or there would be no benefit out of that. So this kind of things. Smaller mammals, they are have a disjunct population. For example, in the South Bengal landscape, it is a huge healthy population. We have a healthy population of fishing cats, but they have disjunct distribution, and we do not know whether there is gene flow between these populations. So only way to know them is through the genetic analysis, and such people are interested. Maybe some of the scientists who have gathered over here might be interested in a problem like that and take up the challenge. Or another interesting area of our work is stress assessment in elephants. Those who are from West Bengal don't know, they know that the stress caused on the animals, particularly elephant, is a major issue, and this translates into human-animal conflict. So we wish to find out what is the stress level in the wild elephants, but this is not a easy job. So one of the methods is to collect the tail hair. When we tranquilize the animal for translocation purpose, we collect a tail hair, and the tail hair accumulates cortisol year after year. So it gives like a chronology, it gives a history of the stress of that animal. So using that tail hair of say South Bengal animal and a North Bengal animal where it is comparatively in peace, we can find out how much stress is there in the South Bengal animals, and to find out a strategy. This thing, this work, we had to hunt for so many persons who can do this work, and ultimately one gentleman, one professor, he agreed to do it for us, and this kind of work will have a lot of applied applications for us. We are using eDNA, environmental DNA, to find out presence or absence of
highly endangered, extremely critically endangered species like Vatagubaska, the northern river terrapin that you might have heard, that only we have a few individuals in Sundarbans and nowhere else in this world those animals are there. But recently we found certain wild-caught animals also. So eDNA we are resorting to in order to find out whether there are any animals in the estuary, and if so, we want to know the diversity level of them, because our captive bred animals are more or less had a very low genetic base. It all started from 8 individuals, now it is 470, but you know the genetic diversity is very less. So the future prospect of survival of the species depends on how many animals are there in the wild, and we are trying to find that out through eDNA. We of course use genetic data for animal reintroduction program. When we captive breed some animals, of course its genetic profile is analyzed. We try to find out which area it should be released so as to add to the genetic diversity of that area. There are false attempts. I will end with this. Very recently, our sister organization WII tried to estimate the number of elephants using dung data. You know, the mucosal layer around the dung contains the elephant DNA, and I do not know where it gone wrong. There may be so many places where it may go wrong. The dung collection, the age of it, preservation, polymorphic loci identification, so many things, but it did go horribly wrong. Southwest Bengal elephant numbers showed only 34 or 35 individuals, but there are, we see daily 200 odd individuals are there. So, as I said to my boys, that DNA doesn't mean everything is perfect. It's the person who is using it, the technology that is being used, that is important. So, in evolving technology, ethical areas, everything has to be taken with a pinch of salt before the technology is standardized, and then we know, yeah, the figure is acceptable. Uh, I am more or less outsider to this kind of highly talented scientific gathering, uh, but I take an inside view, as I said, and I really love the work that you are doing, and I am sure, pretty sure, that the exchanges between the brilliant brains that will take place in next 3 days will trigger so many ideas and so many new paths of collaboration. I wish all the success to this program. Thank you.
Thank you very much, sir, for your vivid deliberation and your gracious presence today. Now it is the time to release the compendium of abstracts of National Symposium and also the newsletter of SVBBI and the book published by SVBBI. The Chief Guest, Professor Dhruva Chattopadhyay, is kindly requested, along with other dignitaries, to release the same. The compendium of abstracts of National Symposium the National Symposium on Advancing Animal Health and Production through Biochemical and Biotechnological Innovations. The compendium is given. Now the newsletter of the society will also be released. The newsletter of SVBBI is released. The book published on animal biochemistry and biotechnology will be released. The book by Partho Saruthi Behra, Aditya Prasad Shao and B.P. Mohanty. It's the instant notes for ARS main examination, including solved previous year's papers also. Book on animal biochemistry and biotechnology, published by NIPA Genex Electronic Resources and Solutions Private Limited, New Delhi.
We will now proceed to felicitate our esteemed dignitaries and guests on the dais. So, I would like to request Professor Tirtho Datta, Honorable Vice Chancellor of our university, to felicitate Professor Dhrubajyoti Chattopadhyay, the chief guest and inaugurator of this session. Dr. T.K. Datta is requested to felicitate Professor Yu Truel, special guest of this conference. Again, I would like to request Sir to felicitate Dr. Mihir Sarkar, guest of honor of today's session. Sir is requested to felicitate our guest, Sri Deval Rai, guest of honor of today's session. I would like to request Professor B.P. Mohanty sir to felicitate our Honorable Vice Chancellor sir, Dr. T.K. Datta. Again, I would like to request Dr. B.P. Mohanty sir to felicitate Professor Partho Dash, Registrar of this university. I would like to request Professor Subhashish Bhattacharya, Organizing Secretary of this conference, to felicitate Professor B.P. Mohanty, President, SVBBI. Again, I would like to request sir, please felicitate Professor Nilotpal Ghosh, Dean, Faculty of Veterinary and Animal Sciences of this university, and Chairman of this conference. I would like to request Professor B.P. Mohanty sir to felicitate Professor Subhashish Bhattacharya, Organizing Secretary of this conference.
I will request our Honorable Vice Chancellor sir to take the pen to felicitate off the dais our former Vice Chancellors and other former Vice Chancellors and other guests who are off the dais. Sir, you have to... Okay. So nice of you, sir. Professor B.B. Mollik, former Vice Chancellor of this university, is being felicitated with memento and shawl. Professor Purnendu Biswas, former Honorable Vice Chancellor of this university, will be felicitated. Professor Purnendu Biswas, former Honorable Vice Chancellor of this university, is being felicitated. Professor Chanchal Guha, former Honorable Vice Chancellor, WBUFS, will be felicitated by our Honorable Vice Chancellor Sir, Dr. T.K. Datta. Professor Shyam Sundar Dana, former Honorable Vice Chancellor of this university, will also be felicitated. He is being felicitated by our Honorable Vice Chancellor, sir. We are having with us Professor Shankar Kumar Ghosh, former Honorable Vice Chancellor, Kalyani University, Nadia. Dr. T.K. Datta, Honorable Vice Chancellor, sir, is requested to felicitate Professor Shankar Kumar Ghosh, former Honorable Vice Chancellor, Kalyani University, Nadia. Thank you. Thank you. We convey our gratitude to the dignitaries and the guests who have been felicitated here. We wish for your good health. Next, the organizing committee of SVBBI is requested to conduct the awarding ceremony for different awards of the society being presented here.
First of all, on the behalf of organizing committee, actually as we are celebrating as we are celebrating 25 years of Veterinary Biochemistry department also, so our respected teachers, so we want to felicitate Professor Sagar Sannal, I think sir, not coming yet. Professor Dalin Kumar Nandi, sir, you are requested to, I request our Honorable Vice Chancellor and Chief Guest. Chief Guest. Dr. Soibal Chattopadhyay. Dr. Soibal Chattopadhyay. I think. Moini Saini ma'am, our teacher. Our beloved teacher, Dr. Ashim Kumar Pal, sir. Our beloved teacher, Dr. Paritosh Joshi sir. Ayurveda. Sir, please. Professor Rajesh Nigam sir. Nigam sir, please. Satya Sharma sir. Dr. Mihir Sarkar, Director of NRCI. Now I will request Mohanty sir and Dubojiti sir to give honor to our Honorable Vice Chancellor, eminent biotechnologist, Dr. Tirtho Kumar Datta sir. Now I request Dr. Sochi Nandonde, National Professor, ICAR India. Sir, please. Another national professor, Professor Shobit Kumar Nandi, ICAR National Professor, Department of Veterinary Surgery and Radiology, WS. Professor Nandi. Now we are going to felicitate two eminent personalities in the field of poultry sector. So industry and academia relationship. Professor Manik Chandra Pakhira, Professor, Department of Avian Sciences, West Bengal University of Environmental Sciences. Now I will request another eminent scientist poultry specialist, immense contribution in the field of poultry, Dr. Abhijit Mishra. Dr. Abhijit, please. We are also offering, but I think they are not present, Dr. Gauri Shankar Kunar, CEO PBGSBS, and Dr. Utpal Karmakar, Managing Director WBLDCL, and Dr. Pushpendu Paja, he is also in our ERD department. So I think in valedictory session, if they are present, we want to, and Dr. Captain A.G. Bandopadhyay, he was former director. So I think in valedictory session, they may even present. Thank you, sir. Thanks, Mohan. Now, sir, please. Our SVBBI award. Some awards are here on the behalf of SVBBI. This is SVBI Award, prestigious Dr. Ellen Singh Memorial Award goes to Professor Rajesh Nigam, former Vice Chancellor of DU Vasu and former Professor and Head, Department of Veterinary Biochemistry, DU Vasu, and former Dean also, Division of Biotechnology, DU Vasu. Sir, please. Dr. Rajesh Nigam. SBBI Fellowship, Dr. Mrs. Manju Roy from Durg Veterinary College, Ramdev University, Chhattisgarh. Thank you, sir. Dr. Sanjeev Kumar Bhure, Principal Scientist, ICAR, IBRI, Bangalore campus. Bhure, sir, please. SBBI Fellowship. SBBI Best Teacher Award goes to Dr. Sanju Mandal. She is in Jabalpur, College of Veterinary Science and Age, Indiu Bhasu, Jabalpur. SBBI Best Teacher Award, Professor Dr. Dalby SH from Mumbai Veterinary College, Mapsu. Dalby, sir, please. SBBI Senior Scientist Award, Professor Dr. R.A. Siddiqui from Basu, Patna. Siddiqui, sir, please. SBBI Senior Scientist Award, Dr. Barkha Gupta, Raju Bhas, Jaipur. Thank you, sir. Thank you, Vice Sir. Thank you, Regis Sir. Thank you, President Sir. We are having some awards, but this is competition will be held on tomorrow. Young Scientist, SBBI Young Scientist Award, Best PG, Best PhD thesis. These three category will be, that is in competitive mode, that will be held in tomorrow, and in valedictory session, we will give the award. Thank you very much.
Congratulations, those who have received the prize, those who have received their medals and awards. Please extend your applause to all the awardees of SVBBI.
The academic as well as administrative torchbearer himself, Honorable Vice Chancellor of West Bengal University of Animal and Fishery Sciences, Professor Tirtho Kumar Datto. Sir, we kindly request you to deliver your presidential speech.
Good afternoon to all of you and most respected dignitaries of the dais, Dr. Chatterjee, Mr. Deval Roy, Dr. Neer Sarkar, Dr. Mahanti, my colleagues, Dr. Partha Das, Professor Devatpal Ghosh, Dr. Truen, and very renowned ex-vice chancellors of this university, Dr. Devi Malik, Professor Punandu Biswas, Dr. Chanchal Guho, Dr. S.S. Dana, and all my friends and dignitaries, Shankar Ghosh, ex-vice chancellor of Kulane University, and my friends and colleagues. Actually, the organizers scheduled me to speak at 11:35, and now it is going to be 12:10. And somehow I have been trained from my student time to be on time. And somehow I have picked up in my gene that whenever I miss the time, I get tense. And I get tense because of two things. One is, I know all of you, you are waiting for something else. You are waiting for your speakers to speak and the audience to listen and gain great knowledge about it. And when you get late, I get the symptom from the audience that at some point of time, almost 50% they go on WhatsApp. And that gives me a kind of a feedback that probably what I'm speaking is not either relevant or you don't want to listen, something like that. But still, I will try to keep it short. I have been given 10 minutes time. I will not speak. I like the, whenever, I think after I became the Vice Chancellor of this great university, or for that reason any university, the Vice Chancellors are offered to speak at the end. And since morning I was preparing that what to speak and what not to speak and like that. I made a note, but by the time you listen to all honorable speakers, you feel that your note is exhausted and nothing new to speak about this. So I will better keep my notes out and I will extend more. And let's speak about my little bit of the life experience and kill 10 minutes time, right? It was 1986 when the term biotechnology was in air. Okay, so our then Prime Minister, Mr. Rajiv Gandhi, he imported this term from somewhere, I don't know. He had a great associate, his name was the beard man, what is that name? Petroda. So both of them, they promoted this term and we were students and we entered into a debate. Debate is that what is biotechnology? We had virology, we had mycology, we had bacteriology, we had immunology, we had preventive veterinary medicine and vaccinology and all that. So we entered into that race and some of them are there. Parveen, you are there, Parveen is there and Sachi, my very old friends. So they got trapped into this biotechnology in 1986. I find that this particular society, it was established in 1995. So you took about 10 years time to really understand what is biotechnology and what is its prospect and is the industry ready to get biotechnology, because whenever there is to be a job opening, people used to say, I have an immunologist, I'm looking for a recombinant, protein to be expressed and doing that. So you are biotechnology, you wait for your turn, something like that. So after 40 years, now I find that the euphoria of the biotechnology terminology is over, and now the industry is mature. And then industry is trying to find new applications, and the academic system, the universities, they have also crafted their curricula to make the graduates, biotechnology graduates, market ready for doing it. This is a very good development. In 1986, I am a basically geneticist, but somehow I also got trapped into the Department of Biotechnology. There was a mega project on embryo transfer. So people were telling that this is going to transform the Indian livestock, and I got trapped into that, but I enjoyed working with round objects for throughout the life, and here what I am. And I must tell you something that for the first time, Reena, you are here, Reena, where is Reena? So I have seen the first PCR machine into her lab. Okay, it was in 1990, and believe me, we used to cross 3 glass doors, right, to reach to the PCR machine. And people said that this is something great happening over there. And my friends who used to run the PCR, when I used to call them on intercom to say that should we go for a cup of coffee, they would say, no, I am busy. And what for you are busy? And my PCR is going on. So he befooled me, and after about 10 years, I came to know that when your PCR is going on, this is the pure free time to enjoy your coffee. Right? Because you have nothing to do, machine is doing its purpose, its job and all that. But having said that, the first time I did PCR, it was at Banaras Hindi University. I was in a sabbatical, and I was under a very great professor, if some of you know, Professor Lakhotia, Subhash Chandra Lakhotia, SC Lakhotia. So he gave me 3, water baths set in different temperature, and a very cheap Chinese watch by which you can measure the time of 30 seconds and 40 seconds and all that. And then finally, when your product comes, you run a gel, and then you see your DNA and all that, and then you have it. Then I found 2 class of people, some class who know DNA and some class who does not know DNA. Today, from Debal, I learned about another DNA, that is EDA. And this is something exciting. So this is how any subject, it gets mature. And currently we are talking about system biology. What is system biology? System biology is a subject where everything assembles together to understand a system. It's not that. I think, Sohini, when this omics euphoria started, I was just sitting over there and trying to find out a Wikipedia on omics. There are 52 omics as of now. And the most interesting omics I found is cryobolomics. Cryobolomics. That means when you take a cell into minus 196 degrees centigrade temperature and you feel that something is happening, something is not happening, so it is probably a subject worth looking at. So I thought of writing that please add one more terminology, omics, saying it at other omics, because you keep the window open for the other omics to come, and also write nonsense omics over there, because many of these omics, I am sure they're eventually going to die, because they have been created out of a euphoria. So when the euphoria is over, then it is done. I'm sorry, I'm not hurting anybody's sentiment over here. So the net message that I wanted to give to this august body is that whatever academics we do, be it biochemistry or biotechnology or physiology, because biochemistry ultimately is a mother subject, right? Everything, it circles around the, sulfhydryl bonds and the double bonds and this and that. I was just talking to Asimda that I was always afraid of this biochemistry because I never understood it properly. But at some point of time, I got clueless, thinking that nothing more was happening. So then you go back to the biochemistry and then you start understanding a molecule. I'll give you an example. About 10 years back, I took a challenge. Challenge was that, in the current frozen cement technology, Nigam Saab, frozen cement technology. In the frozen cement technology, we currently pack about 20 million spermatozoa per dose. Okay? So I challenged. I said that can we make it 10 million? Because if we do that, then my frozen cement production becomes double overnight. So how to do that? So I entered into the uterus and found what the bloody sperms are doing over there. Then I find the mononuclear, the lymphocytes, they are engulfing some of the spermatozoa. And then my passion for the biochemistry started. Then when I look at the head of the sperm, you find it is very sweet. There is a lot of sugar over there. And then I came to know about there are two kinds of glycosylations. One is the N-linked and another is the O-linked. And when you tickle with the one, so this probably helps spermatozoa to get protected in this. My colleague Rakesh is there. So even I think still he is taking this story on. So likewise, so when you do biochemistry and you do deep science, and because whatever science you do ultimately, if the science does not answer the question that you have asked, then you leave it, unfinished. Okay. So I'm sure that who else will teach you biochemistry better than Dr. Paritosh Joshi? I mean, he remained my teacher, and he's the finest biochemist, I must say. And it is those days in IVRI, Professor LLC, Paritosh Ji, USC, Nigam, and I'm not naming everybody, but they were excellent teachers and excellent human beings. This conference, all this success, you discuss threadbare about the subject and whatever papers that are presented and ask questions, and along with your academics, you have a lot of fun also. Here people are there from all over the India and all over the world. So this gives you excellent opportunity to network, to make new friends and find new collaborators. Okay? And I, on behalf of the university, I welcome you all to this city of joy, Kolkata. And this is a fantastic city. All the beautiful ladies who are sitting over there go for shopping, buy sarees from here. And our handicraft industry is very, very famous. And find time within your busy schedule to enjoy Kolkata and enjoy your biochemistry. Thank you very much.
Thank you so much, sir, for your valuable words. Now this is
We are almost in the end of this inaugural session. Before vote of thanks, one announcement is there. Respected guests and delegates, we have a dinner program today in the cruise on River Ganga. The vehicle will move immediately after the today's last session, scientific session. Delegates and guests are requested to avail the respective buses by which you arrived here in the morning. Those who are staying at Veterinary Council, Farmers Hostel, Shubhak Khan and IVRI Guest House are requested to move by the university bus. That is number will be given in the your delegate group. Rest of the guests of Belgacia are requested to move by bus number 19K5383. Our volunteer will assist you. Thank you very much.
Thank you, sir, for this announcement, and this is the time to almost end of this session. So now I would like to invite Professor Nilotpal Ghosh, Dean, Faculty of Veterinary and Animal Sciences and Chairman of SVBBI CON 2025 to propose the vote of thanks.
Namaskar, respected dignitaries, distinguished guests, ladies and gentlemen. On behalf of the organizing committee of 9th Annual Convention of the Society of Veterinary Biochemists and Biotechnologists of India and National Symposium, it is my pleasure to propose the vote of thanks. First, I extend our sincere gratitude to the Chief Guest, Professor Dhrubajyoti Chattopadhyay, Honorable Vice Chancellor of Sister Nivedita University, Kolkata, for his gracious presence in this occasion and for inspiring inaugural address. Sir, your insightful words have set the perfect tone for this symposium. I also take this opportunity to convey our heartfelt thanks to our special guest, Professor Yu Truen, Director of the Institute for Animal Hygiene and Veterinary Public Health, Leipzig University, Germany, for your gracious presence and valuable message to the gathering. Our special thanks go to our guest of honor, Dr. Mihir Sarkar, Director of the ICAR NRC IAC Arunachal Pradesh, and who happens to be alumni of this institute, and also Sri Deval Rai, IFS and Principal Secretary to the Government of West Bengal, for joining us and offering your warm wishes and encouragement. I extend our sincere gratitude to all the former Vice Chancellors of our university who are present here, Professor B.B. Mollik, Professor Purnendu Vishwas, Professor Chanchal Guho, and Professor S.S. Dana, and also Dr. Shankar Ghosh, former Vice Chancellor of Poland University, for your gracious presence in this occasion, sir. We are deeply grateful to our Honorable Vice Chancellor, Dr. Tirtho Kumar Datto, who presided over this function. Sir, your leadership and vision and constant support have made initiatives like this symposium possible. We are truly privileged to have your guidance. Our heartfelt thanks to Professor Bimal Prasanna Mohanty, who is former ADG of ICAR and other leaders of the society, the SVBBI, for allowing us to organize this mega event. I also express our gratitude to the Registrar of our university, Professor Partho Das, Joint Registrar Dr. Saurabh Chandra, who is also nicely anchoring this event, Dean of Fisheries, Professor Nagesh, Dean of Dairy Technology, Professor Bagh, DSW, Professor Pankaj Vishwas, and other officials for their presence and wholehearted support. Our sincere thanks to our keynote speakers, session chairs, and resource persons who will enrich this symposium with their expertise. And my heartfelt appreciation goes to the organizing committee, faculty colleagues, research scholars, student volunteers, and support staff for their dedicated effort to make this event possible. And I also thanks on behalf of the organizing committee to all the biotechnologists and biochemists and award recipients who received our felicitation on this occasion. And I also extend our thanks to the valued sponsors for their support and also the media persons who are covering this program. And finally, I thank all the participants and delegates for joining us in this event. Your presence encourages us and contributes immensely to the success of this event. Thank you all once again, and we look forward to your active participation in the sessions ahead. Thank you.
Thank you to the thank giver, Professor Nilotpal Ghosh, Dean, Faculty of Veterinary and Animal Sciences, and the Chairman of SVBBI Con 2025. The national anthem will now be played. All are requested to stand on their space and sync with the symphony. Our students are advised to lead the singing of national anthem.
अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मागे गाहे तब जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Hearty thanks to all you here. With this, we conclude the inaugural session.
We request all the delegates to proceed for the next scheduled technical session, but before that move towards the refreshment area to have a refreshing high tea. Thank you everyone. Have a wonderful day ahead and enjoy the convention. Hello. Professor Siddhartha Joardar. Professor Siddhartha Joardar is requested to take over the charge of the dais for technical session.
Sector 5. अरे ये तो पूरा ट्रैफिक हो गया इधर मेन सर्कल से हाँ मेन सर्कल निकलना है फिर मिलते हैं किसका है
Professor Siddhartha Joardar is requested to come inside the hall and take over the charge of the dais for technical. Oh, okay, thank you.
चाय पी के आते फिर
इधर है क्या आपका इधर है क्या क्या पता चला चाय पी लेंगे तो
मिल लेते पहले आओ
सरकर सर से मिलो
हाँ
आपके
Like when is your, section?
Afternoon.
If you have some time after your presentation, you can just drop it. Yeah, you'll be going to the quiz. And they'll be doing from here. Depending on. Yeah, because I'll be here. January. Yeah. So that's like whenever, go on a holiday. Like let's see, today if you have time. Then you can come in. Yeah. You'll be there. Yeah, first session.
ফার্স্ট সেশন কোথা থেকে চালু হবে ফার্স্ট সেশন কোথায় হবে চলো
कार तो दिया नहीं सर को पकड़ नहीं पा रहे हैं, हम उधर जा रहे हैं, सर उधर जा रहे हैं। सर नमस्ते सर। सर कैसे हैं? पकड़ नहीं पा रहे हैं, हम उधर से आए हैं।
ये क्या है? मोबाइल है, इसका मोबाइल है। है ना? चलिए।
थैंक यू सर। याद करते रहते हैं आपका एकदम
तो
नया स्टार्ट हो जाना कॉलेज का।
हमें बातचीत होते रहते, आज सुबह बात मेरा
এখানে বসে আপনার পুরো প্রায় 5-7 মিনিটের
সঙ্গে কথা বলো না, আমি একটু পরে
একসঙ্গে জয়েনিং
ওরা নিচে ওরা ওদের নাম বলে দিলে দেবে না। আমাকে রাহুল বলছে যে
আমাকে বললে হবে না, ঘটবেল স্যার ঘটবেল স্যার এই যে বয়স্ক লোকের সামনে যে কথা হচ্ছে।
আপনার একটা কার্ড দিন।
কাট দিচ্ছি। চলে যেতে হয়। এই গৌতম,
এই পূর্ণেন্দুবাবু কোথায় চলে গেল?
আমি আসি বাবা, আমি প্রয়োজন ছাড়া আসি না, কারণ আমার তো অনেক দূরে কাম আছে। মানে অনেকদিন পর দেখলাম, অনেকদিন পর। আমরা সবই একই দলের।
আলাদা রুম আছে লাঞ্চের ওখানে। ভাই আর তো 6টা ফোন লাগে, 6টা হল চার্জ থাকে মুহূর্ত ফোনে। হ্যাঁ কেমন থাকে? এই 90 দিয়েছিলাম, এখন 41 আছে। ক ঘন্টা হলো? 10:30 থেকে 12:30। ভালোই চার্জ খাচ্ছে। জিওতে তুই অন্য মোবাইলে হলে তো পারে। আমার এখন নির্বাচন হয়ে গেলে 18 ফুল রানিং। কি ফোন? আমার কাছে রিয়েলমি। কত এমএএইচ? আমার 5000। তোর 5ই? আমার বেশি তো 5900। ফুল স্টোরেজ পাই। কিন্তু ও বলে লাভ নেই, যেটাই যেটা দাম। কিন্তু ভিডিও করলে আর নেট চললে অনেক নেট যায়। টাইম ল্যাপস গুলো তো বুঝতে পারছিস কত টাইম লাগে মেঘে। 12 ঘন্টা রোদের মধ্যেই থাকে, কন্টিনিউ চলে যায়। কিন্তু রোদের হিটিং গুলো তো চার্জ ফোন সুইচ অফ হয়ে যায় না অটোমেটিক। হাটফুলার তো এটা পেয়েছি ভালো। আরে তুই আয় না, সব থেকে হার্ডি আমার মনে আসুস। আগে আসুস আমি ব্যবহার করেছি। আসুস, হ্যাঁ ওটা অনেক সেরা ফোন। যাদের তো ভালো লাগে। সাবস্ক্রাইব করতে বলে দেবো নাকি সামনে গিয়ে? বলে দিবি একটা। স্যারকে বলে দিবি। স্যার প্লিজ একবার বলে দিবি ইউটিউবে এই হচ্ছে সাবস্ক্রাইব করে। হ্যাঁ এই লাইভ হচ্ছে। স্যারকে বলতে হবে, এই কপল স্যারকে বলে দিবি। বলে দেবে স্যার। যে কমিটিতে আছে কনফারেন্সে, ওই কমিটিতে লিংকটা দিতে হবে। তুমি কমিটিতে আছো? বায়োকেমিস্ট্রি, হ্যাঁ আমি আছি। দিও, পাঠাও লিংকটা দিয়ে আমাকে পাঠা। এই সার্চ করো। সার্চ করবো ইউটিউবে যাও হচ্ছে করা আছে কি জানো PETMAT ও ভেটম্যাট MATE স্যালারি করা নেই ভেটম্যাট ইঞ্জেকশন সাবস্ক্রিপশন করা নেই লাইভ চলছে এটা আচ্ছা এটা আবার কী করবো এখান থেকে শেয়ার করবো শেয়ার করে কপি করবো স্যার কিছু বলে বলো একটু না করলে কী হলো এটা নেই তো তুই না তাহলে ডবল করে না গেলেই হলো না ওয়েট করতে হতো তাহলে এইটা চলে আসতো থ্যাংক ইউ কী করতে হতো বল একটু ওয়েট করতে পুরোটা চলে আসতো নাকি ডিলিট করে দে পুরো ডিলিট করে দিলাম এবার কপি কর পেস্ট কর আসবে তো দাদা ডাইরেক্ট ওখান থেকে এটা ড্রাপ হয়ে যাচ্ছে দাদা এটাকে কেটে দিই এখান থেকে টিকেটি স্যার এখন ফোন করবে ফিরে কি দিচ্ছ কি ডিলিট করছি স্যার ওসব বলা যাবে না পার্সোনাল এই চলে এসছে কিন্তু দিয়ে দেবো কি এবার নেট তো এখানে সবারটা চলছে না ভালো ব্যান্ড আছে তাও চলছে না কেন কি জানি তো আবার ওখান থেকে ই করি এত নকশা করে লাভ নেই এটা কেটেই দিই কেটে দিলাম একদম ডাইরেক্ট ওখান থেকে শেয়ার করো কপি করতে শেয়ার একদম ডাইরেক্ট শেয়ার দিয়ে হোয়াটসঅ্যাপ কুইক শেয়ার না হোয়াটসঅ্যাপ ও আচ্ছা হোয়াটসঅ্যাপে গিয়ে ওই তো যাই সব খুশি সব খুশি খাবো জীবনটাই তো খেয়ে শেষ করে ফেললাম অনেকজন দেখছে তো 4 জন দেখছে ভাই কনস্টিতে 25 জন দেখছে এসবি কানে খুব কম 2-1 জন তাও অনেকজন মাঝে মাঝে 10 জন 11 জন 20 জন পর্যন্ত চলে এসেছে
ভাই ভয়েস মেসেজ না
চলো নিচে চলো খেয়ে আসি তাহলে বন্ধ করে দে চার্জে লাগিয়ে দে হ্যাঁ চার্জে লাগাবো
পাবলিকের উপর তুমি কি গোলাম দিতে পারছো হ্যাঁ সে তো আমি জানি আচ্ছা ভালো
সবাইকে ডেকে নিয়ে আসে আইটিতে গেছে তো হ্যাঁ ওরাই তো করবে
বলা যাবে স্যার
এখন কি আছে না
এখন ওই তোমার ইয়ে প্রেজেন্টেশন
এখনই ভালো হবে ওরাল
ওরাল
দেখতে ভালো কিছুই বেকার কিছু ইয়ে বলে
আগেরবার যাসনি তো ওখানে সারাদিন ছিলাম ওখানে
আমরা ছিলাম কিন্তু আমার পিছন দিকে বসে অতটা কি ইয়ে হয়
আগের দিন হেভি ছিল কিন্তু প্রেজেন্টেশনগুলো
কিছু কিছু দেখি
হ্যাঁ আমি দেখেছি
ইয়ং সাইন্টিস্ট
এজিবির কথা বলছিস হ্যাঁ এজিবি তো ভালো ছিল
হ্যাঁ একদম
আমাদের আলী কি বললো কি একটা দাদা ছিল কি জানে কি বললো মোল্লা ছিল আলাউদ্দিন মোল্লা নাকি
হ্যাঁ এরকম কিছু নাম ছিল মোল্লা দিয়ে
সুন্দর বলেছে বেশ
ইয়ং সাইন্টিস্ট কিছু ছিল না কাশ্মীরের একজন ছিল
উনি তো পেয়েছেন
দুজন হ্যাঁ দারুণ
হ্যাঁ ওই মেয়েটা মেয়েটা যা বললো না
আর প্রথমেই
যে মেয়েটা
কলকাতায় এসে খুব ভালো লাগলো এরকম
বাংলায় বলেছিল
ও আর একটা ছিল সাথী বলে একজন ছিল ইয়েতে
পুরা
ওই তো ইয়ং করে না দুটো কোকড়া ছোট
গল্প গল্প আসছিল ওই ও কিন্তু আমাদের ভেটারিনারি নেওয়া কিন্তু জানিস তো ও হচ্ছে মানে
মাইক্রোবায়োলজি
ও বায়োটেকনোলজি পড়েছে মানে নর্মাল কলেজ
আর ওই দুটো বোন যারা কাশ্মীর থেকে এসেছিল দুটোই বিভিন্ন সাইন্টিস্ট একটা
মেডিসিন ফার্স্ট ইয়ার
আচ্ছা
আমার সাথে মেডিসিন পাচ্ছে মানে খাচ্ছেন
বাচ্চারা শুনতে পারবে আমার বাবাকে এখন বুঝছে
सर आपका पीछे हूँ सर यहाँ पे कौन सा कॉमेडी रिसेप्शन
हाँ देख दो
मछली का
তোরাই আমার মুখ থেকে দেখে
তোরই বলতে ভাই বাবু কি গাল হচ্ছে নাকি তো
আলটিমেটলি দেখে আমার দিদি
তোমার সাথে ভর্তি হয়েছি তুমি
আমাদের প্রথম কাজ আছে যে সতেরো পাতা আর একটা সতেরো চিত্র আর প্রথম কাজটা
ওখানে যাবেন না স্যার খেতেও ভালো লাগে আমি সামনাসামনি আড্ডা মারা একরকম আছে একরকম আছে হ্যাঁ বল সেদিন তো দেখা হলো তো ওই যে রাস্তা ক্রস করছো সবার পরে মানে রাস্তায় অবাক আমি পাড়ায় থাকে বা পাশের পাড়ায় থাকে নিজের বাড়িতে থাকে ওখানে কি দু চারটে কথা বলা হয়েছে
স্টার্ট করাটা খুব চ্যালেঞ্জ
অনেক 15 কোটি টাকা এনে দিয়েছিল যে ওয়ান হেলথ একটা বড়
आयुर्वेदिक कहाँ है
वो नीचे भी चाय पी रहा था
बोलन
सर आपको जो मिलती
ना ওইখানে
नहीं हाँ ये तो आजकल सबका हो गया ये भी तो हो गया था कलर किया है कलर किया जी हम लोग मौसमी जूली अभी अभी आया है
বড় হয়ে গেছে বড় হয়নি স্যার সবসময় টিচারদের নিচেই আছে
কেমন চলছে তোমার বলা
চলছে ঠিকঠাক এখন
স্টাফ ওখানে কোথায়
তবে মনে হচ্ছে কিছু
তোমার এখানে
রিক্রুটমেন্ট
প্রেজেন্টেশন আছে তোমার
না প্রেজেন্টেশনের
একটা ফটো তুলে নেবে নিয়ে দেবে
হ্যাঁ
আমার ড্রাইভারটাকে খাওয়ার ব্যবস্থা করতে হবে এখানে খাওয়ালে
দিতে হবে বলে দিতে হবে
আপনি বলে দেবে হ্যাঁ আমাকে বলে দেবে আমি আসে খবর করে দেবো
ফোন করে দিই কাউকে বলে দেবো
আমি ফোন করে দিই
হ্যাঁ
সুভাষিস তো
হ্যাঁ হ্যাঁ বলে বলে দিন
তোমার মেয়ে কী করছে
মেয়ে স্যার এমটেকও করে ফেলেছিল ইন্টিগ্রেটেড মাদ্রাস থেকে কম্পিউটেশনাল ইঞ্জিনিয়ার
হ্যাঁ
কম্পিউটেশনাল ইঞ্জিনিয়ার তারপরে ইউনি অরবিট বলে একটা কোম্পানিতে জয়েন করেছিল যে বছরখানেক করার পরে বললো না আমাকে এআই যেতে
হ্যাঁ
এআই যেতে হবে
হ্যাঁ
এখন আইআইএসসিতে একটা এতে জয়েন করেছে রিসার্চ প্রজেক্ট ইন্ডিয়ান ওখানে 1 বছর 1.5 বছর পড়তে করে তারপরে ওই বিল্ডিং জার্মানি ভালো আছে একটা পেপারের জন্য জয়েন করেছে একটা পেপার হয়ে গেলে পরে
দুটো পেপার হতো আমার একটাই মেয়ে তো
আচ্ছা আপনার ছেলে মেয়ে ইংল্যান্ডে দুজনে
ছেলে
লন্ডনে আমার একটা বহুদিন থেকেই আছে
আবার যাওয়া হয়ে গেছে বাড়ি বাড়ি
লন্ডনে আমার বিশ্বত দাদা বহুদিন আগে ওখানে সেট এসছি ওই বিয়েতে এসছি এসছি মাস করে থাকতে ওইখানে
We'll be coming down. Okay. I'll be in touch. Your brother is good?
Yes, sir.
বলে দিন হ্যালো আপনি কী হয় অন্য বাইরে খেয়ে
ওটা তো একটু তো বিজি আছে
হ্যাঁ হ্যাঁ আমরা মানে সিকোয়েন্সটা করায় ওরা ফ্রম সিনজেনিক্স আমি আই জাস্ট বিং দ্যাট
ডেলিভারি করে দিয়েছেন?
হ্যালো হ্যালো।
বাড়িতে দিয়ে দেবেন, বিকালবেলা দিতে গেলে আমরা তিনটের আগে দিতে হবে।
I welcome all the delegates in this 9th annual convention of Society of Veterinary Biochemists, Biotechnologists of India, SVBBI, and National Symposium on Advancing Animal Health and Production through Biochemical and Biotechnological Innovations. From our scientific committee of the organizing committee, and on behalf of that, I am Dr. Siddhartha Naranjawarkar. I am a professor in the Department of Veterinary Biology and now the chairman of the Scientific Society. With my team, I cordially invite you to the hall for starting this program. Now, our program will be starting with the plenary session for 1 hour, and then it will be followed by lunch, and then we have to go for technical sessions 1 and 2, one from this hall, second from the ground floor, and third will be next day, but 4th, 5th and 6th will be in the other building, DRA building. So let us start without wasting time, we are running late. So we are going to start the plenary session. So our speakers will be Professor Dr. UN Truyen and Dr. Sachinananda Dey. I will call our guests afterward, but now I am calling the chairpersons of this session and report here. So chairpersons will be Professor Dhrubajyoti Chattopadhyay, the Pro-Chancellor of SNU and Central Academic Leader of Techno India Group Universities, Professor Punendu Biswasa, former Vice Chancellor of the SVBBI University of Animal and Fishery Sciences, and Dr. Ashwin Kumar Pal, former Joint Director, ICR, Central Institute of Fisheries Education, Mumbai. I just request Sir Professor Dhrubajyoti Chattopadhyay, Professor Punendu Biswas, and Dr. Ashwin Kumar Pal to come over the dais, please. Our guest speakers will be Professor Dr. U.A. Truyen, Professor for Animal Hygiene and Control and Epidemic Diseases at the Veterinary Faculty of the University Leipzig and Director of the Institute for Animal Hygiene and Veterinary Public Health. Professor U.A. Truyen studied veterinary medicine in Germany 1981 to 1986, did his postdoctoral studies in Hanover and Munich, and as a postdoctoral fellow in Collins Parrish Laboratory in the Baker Institute at Cornell University, Ithaca in New York, USA. He was professor for molecular epidemiology at the Ludwig Maximilians University in Munich, professor of epidemiology at the University of Leipzig, chairman of the Scientific Advisory Board of the Federal Institute for Risk Assessment and German Standing Veterinary Vaccination Committee. He was the Dean of the Veterinary Faculty, Leipzig University from 2010 to 13. He has been working, amongst others, on the molecular epidemiology of animal parvoviruses and caliciviruses, on hygiene management in animal husbandries, antimicrobial resistance in activation of airborne viruses and bacteria, vaccination of animals, and One Health and global health concepts. I now request Professor U.A. Truyen, followed by Dr. Sachinananda Dey. I will call. Please. Just missed two things. Report here also I should call Dr. Arnav Sen, Head Principal Scientist and Station in Charge, ICR IVRA Regional Station. Please come over the dais. Dr. Shantanu Bonik, Head ICR NDRI Eastern Regional Station. Beg your pardon, please come over the dais. Here. I request Professor Truyen to come over the dais, please. I think within 15 minutes I will cover. 15 minutes. Okay. Within 15 minutes. Otherwise, 25 minutes. If can, 20 minutes also. It is up to chairman. Sir,
Dear colleagues, thank you very much for the invitation and for the opportunity to speak here about a project which I like very much, and which gives us a sort of perspective of what can be done against AMR in low and middle income countries. And I will talk about our African One Health Network for Disease Prevention with the abbreviation of ADAPT. And this is a project that was funded by, or is funded by the federal government with a total volume of 7 million euros. And it has different partners. Most importantly, I started up with 6 African, sub-Saharan African countries: Senegal, Ghana, Nigeria, Democratic Republic of Congo, Sudan, Ethiopia, and Uganda, 7 countries. And two institutions in Germany, of course, our institute at the University of Leipzig, but also, and this is very important for the topic, closer, not loud enough, is that better? Is that better? And the German federal, I don't think it works, right? Yes, now it works. Okay. And this is important because this is a German National Reference Laboratory for antimicrobial resistance. Next slide, please. The topic is well, as I said, to talk about AMR, antimicrobial resistance. And this is a particular challenge in Africa. Well, it's a challenge throughout the world, but a particular challenge in Africa is the highest rates of AMR. And I think it's true, and it makes sense to call it a silent pandemic because it causes so many diseases and deaths compared to other known diseases. Next slide, please. Can I forward the slides by myself, or? Okay. So this just summarizes the goal of our project, which started in 23. We want to build the capacity across 7 African countries for the improved management of AMR and NTDs, neglected tropical diseases, and for the improved stewardship of the microbials using a One Health approach in partnership with state, local, and regional stakeholders. And this One Health approach, I think it's particularly important, or our institute is sort of particularly interested in this One Health approach, as animal hygiene just sort of covers exactly the borderline of human health, animal health, environmental health, because we do zoonotic agents, we do animal health, and we do environmental studies. So the I think very nice design of this network is that there are several working packages, and what is very important for us when we designed this, they are all headed by African partners. So it's German money that goes to Africa and is managed by African partners. There is some research, as shown here. I can't go into details a bit later. And there's the project management realized at the Makerere University in Uganda. But the overall goal of this network, of this project or network, is, as I said, capacity building and education and policy maker engagement. So what we hope at the end is that by educating people, by training scientists, medical doctors, veterinarians, that we can sort of at least reduce the problem of AMR in those countries. Next slide. Okay, and this gives you very brief sort of cartoon of the different research packages that are part of this network. And starting with task 1 is we do in all these 7 countries a small surveillance study. This is not meant to sort of define the definite prevalence of all these AMR in those countries, but we need to know what kind of resistances we face in those countries. And we need, of course, the isolates to do testing afterwards. So as I said, One Health approach, so we have samples from humans, from hospitals. We do have samples from animals. We do have samples from products made from animals. And we do have samples from the environment, wastewater, markets and something like that. The second task covers the combination of entities as an infected tropical diseases and AMR, because it is known that there's some sort of collaboration, if you say, on findings of these issues. And we focus on helminth infections and AMR, and the patients are in the samples. Task 3 covers diagnostics. And the diagnostic we use to, or wanted to sort of develop or make better, is the molecular diagnostic of finding the resistance genes. Task 4 is a interesting question because we try to get an idea about how the situation of AMR has changed by the COVID pandemic. During those years, tons of antibiotics were used and tons of chemical disinfectants were used. And we want to know whether that has changed the prevalence or the, let's say, the prevalence of antimicrobial resistance retrospectively. Task 5 is, for me, one of the important parts of the network, and that's the hygiene management. We want to know what are the conditions when the animals are raised, slaughtered, what happens to the feces of the animal, what happens to, are there any sort of contact between humans and animals? And how do the farmers try to get rid of the bacteria? What is the disinfection management? What kind of disinfectants they use? Do they use any? Are they working? And task 6, at the end, sort of summarizes that and tries to make some sort of guidelines or some kind of stewardship based on the results of these other tasks. And as I said, it started in 23, and they are the first results available. And this is very preliminary what I tell you now, but I just want to make sure that you can see that there's some sort of progress. So, as I said, we want to improve the diagnosis of AMR in those countries, and we do that developed by Ahmed Abdullahi, who's sitting in the audience, by improving or changing the mobile suitcase lab to a suitcase lab that employs nanopore sequencing. So sequencing of bacteria in the field with the nanopore is a very, would be a very convenient way to get an idea about AMR. And now, at this time, of course, we need to compare it with the classical methods, but the advantages are very obvious in terms of time and in terms of practicability. Next slide. There are tons of known resistance genes that can be picked up by sequencing, and this is sort of the spectrum we can work on. Next slide. as I said, we started a surveillance study in the sub-Saharan countries. Next slide, please. And the very first experiments were done. We sampled, as I said, different sample types from humans, from chicken, from cattle, from vegetables on markets, and from wastewater. But of course, we had to focus on some germs of some bacteria. And what we do are E. coli, ESBL, and Salmonella. And you see the percentage of positive, and that means of E. coli that have ESBL genes or resistant E. coli are fairly high, at least for the ESBL. And also Salmonella has been found in many samples, and particularly in wastewater. Talking about these co-findings of neglected tropical diseases and AMR, first results were that there is, in some cases, indeed a sort of co-infection of some elements and AMR, and this is mainly done by our colleagues in Nigeria, but again, preliminary results. Next slide. Hygiene management and disinfection. As I said, there are, in Europe we have very well-defined guidelines to test the efficacy of chemical disinfectants. And if you want to license a chemical disinfectant in Germany, you have to show its efficacy. And as we are a European Union, we have harmonized rules. So there are European standards that has to be followed by all the member states for the efficacy testing of chemical disinfectants. So we applied these guidelines to the isolates we have from the sub-Saharan country against standard isolates, and just had a quick look what kind of disinfectants are available in these countries, and if so, do they work? And the next slide gives you a very, very first sort of glance of a table that gives you a summary about the disinfectants that are used in these countries by farmers or in hospitals. The difference with classes of disinfectants and the percentage, the market share or whatever you call it, for the different countries. And now we started to sort of have a look at the efficacy of these disinfectants against the Salmonella and E. coli, as to speak, we had. And just for a very brief, for easy, like to read this paper, I marked the ones that won't work, not work in red. So of like 10 or whatever tested so far, 3 didn't work, at least not at the concentrations that are on the label. So if that holds true, then probably some people think they use disinfection, but maybe it's not very effective. The other important thing, if we talk about reducing AMR, is education. And you need to come to the farmer who uses disinfectants, who does management, that he knows what he's doing and that he knows what he shouldn't do. And for this, one big task is to develop tools to reach the farmer. And one of the tools was started by Makerere University. And this is a smartphone tool that can be used on the smartphone and can answer simple questions to educate the farmer. Next slide. For example, with videos, they can see what you should do, how you should store antibiotics, and so on. Numerous, next, there are, no, one back please, sorry. And the next one of the next things is that you have information about certain antibiotics, what are the features to when you should give them and what. And not shown here in this talk, but there's also some kind of statistics that allows you to say, are there any hotspots of AMR in this particular region? So I think, very powerful tool that can be used and hopefully does what it should do to get a better understanding of how to use antibiotics in the field. We also try to sort of define what the expectation is about people about a kind of study like this, or about the use of antibiotics. And we did this Delphi study and asked several questions. Try to sort of get a consensus, expert consensus, the minimal standards of AMR surveillance, reporting, and the One Health framework for low and middle income countries. So we asked several questions. Next slide. On how a surveillance design should be, laboratory methods, diagnostic capacity, what about the data management reporting, quality assurance of the laboratories, and outbreak detection and response. And we asked medical doctors, veterinarians, and all different kind of people that has something to do with AMR and animal husbandry. Next slide. And that's results. What do they think about optimum surveillance strategy and minimum standards? Their consensus must harmonize human, animal, and environmental data collection. One Health. Scope enforcement must track both AMR and AM usage and prioritize existing critical pathogens, or lists about critical pathogens. The laboratory standards need to sort of be the same as WHO or GLAS implies. Quality assurance has to be, is mandatory, is important, and for example, must be externally controlled. Human resources need to be highly trained and dedicated personnel with, as I said, One Health focal points on the next slide. And in terms of AMA data, there has to be a harmonization, standardized data that can use integrated platforms. Molecular epidemiology, this is something that is possible with the whole genome sequencing, nanopore. But it would be interesting to see if there is AMR in this region, how they are related. Can we say anything about some epidemiology combinations or hotspots? The same with temporal analysis and hotspot, and coming up with a map, a prevalent map of AMR prevalence. So this is something the experts think would be very good to have, and we try to sort of get that accomplished. So, but as I said, this is a network that aims to education, policy making. So whatever we sort of recommend or whatever we find out with our work, it has to be communicated to the community. And this should be done, next slide, with the existing fora in education, health education. And this, and in these countries is particularly AfriHealth and AfriHome, who are sort of part of this consortium, all which is in close contact with us. And they help to deliver what we found within their programs they already started out the years for the last years. And well, you probably all know these graphs of these cartoons. And this has all to be sort of in alignment with the joint plan of action One Health, and in alignment with the, as the next slide please, with the Sustainable Development Goals from the WHO. It covers at least six of the SDGs that are defined. We want to improve animal production by gene measurements, improve AMR surveillance, training master, PhD, and postdocs, strengthen research in affected communities, gender equality, rapid screening, AMR in water, clean water and sanitation, innovative local diagnostic by improving learning. And as I said, the long-term project impact would be, next slide please, not to do high-end research, but to do research to help to build capacity in these countries, to get an idea about AMR surveillance, to develop these digital tools, and some ideas about stewardship. We closely work at sort of any stage of these 5 years with policy makers, talk to them, and try to motivate them to do more about AMR, bringing this from us. And I think what's very important, and that's where quite a bit of money of the whole network ends, is to have master students, PhD students, to be trained in the different countries, including in Germany, and to sort of educate the scientists from tomorrow on this field. And I think that's sort of a very rough ride through adult, and what you see, very highly motivated and nice people working on it. Thank you very much.
Thank you very much. It's a very interesting one because it's really what we could see, the application and whatever things you have done and whatever the impact you have already put up in the conclusion part. But let us have some quick questions from the audience because we don't have much time. Yes, please.
You told no, you'll be investigating the huge quantity of antibiotic used during COVID period and its effect on AMR. Okay. And earlier also for a longer period antibiotics were used. What is your hypothesis? Means in a shorter period huge quantity of antibiotic used and longer period that antibiotic was used, which is impacting AMR with a high incidence.
It's a sort of difficult question because we don't know what happened.
What's the hypothesis?
Hypothesis. I would anticipate if you use lots of antibiotics without indication at the wrong time point, that you will end up with a bigger problem, but we don't know. And what I'm particularly interested in, well, maybe we can see that with the figures, I don't know. There are reports and experimental evidence that at least for some dead chemical disinfectants, sort of the development of resistance uses the same mechanisms. So even if you don't sort of use too much antibiotics, but tons of disinfectants, quaternary ammonia compounds, and you may enhance existing microbial resistance in bacteria. And this is sort of interesting, but I'm not sure whether we can come so far because you rely on data that are available, not available. You can't sort of generate them.
You visualize there could be difference.
Yeah.
That is your hypothesis.
Yeah.
Okay, thank you.
Any other question? Yes, over here. Can you please elaborate briefly? Can you please briefly elaborate this? What is the procedure? Means what do you follow? Means nanopore sequencing you are following. So from the DNA isolation, from the extraction of DNA, and how you process the DNA, and then you go for nanopore sequencing. Very briefly, can you please explain?
I'm not sure that I understand exactly what you said, but if it's...
Contact me, I will share the whole protocol with you. No problem. It's an open, you see, I would like to say something very important. For all adapt,
Use
we have
the
a
microphone.
repository. There is a repository, all our protocol is online, and also the publication of COVID and everything. So if you go to the website, you can go there to our contact information, and we can set the whole protocol. Because it's a free available. Thank you.
Thank you.
Yeah, sir, very informative presentation. My question is that we have seen the scenario of AMR in African countries. So, vis-a-vis other part of the world, how is the situation? Whether this problem remains alarming throughout the world, or it is restricted to the developing country?
I don't think it's restricted to developing countries or low middle income countries. I think it's everywhere prevalent. But the rich countries have the ability to better work against it. I know for Germany, for example, being a vet in Germany and using antibiotics is lots of paperwork. There are huge restrictions. You have to monitor any sort of single amino acid antibiotics that you prescribe for the farmers as well. And none of the farmers and veterinarians like the idea that the usage of antibiotics dropped, I think, by more than 60%. So it works. There are tools. And I think the same holds for the medical doctors in the hospitals. But in Germany, for example, in these countries, it's probably not as easy to buy antibiotics than in other countries. There's only prescription, and if you have free or cheap antibiotics that you can buy everywhere, and if you don't have any sort of medical doctors, or if you don't have any money to pay doctors, then of course you use it. And that's the problem. I think it's a sort of medical problem, but also a political problem.
So solution probably lies that we need to judiciously use these antibiotics, isn't it? So solution probably lies that we need to use judiciously these antibiotics so that AMR problem will not be created.
Yeah, I think so. Yeah, I don't think we can have to use antibiotics because they save lives. And I think we will always have antibiotic resistance, but we should not select the antibiotic resistance. We should treat it accordingly. And I think, well, my sort of picture is that antibiotic resistance is a physiological way of bacteria to get advantage over other bacteria. So that's clever. But if we select them by using it the wrong way, then it's our problem, not the bacteria.
Thank you very much for nice and informative presentations. Okay. So, really it is a wonderful presentation, and we think we learn many things. But I have a little bit query about this. About 700,000 people die with AMR around the globe. So once you have detected that is AMR because of the AMR, or you have analyzed the samples, water samples, or meat samples, or milk samples, whatever may be, and then how you will treat that person? What is the alternate way or mechanism for survival of these AMR patients?
You mean the coloration? To say for sure that this was from wastewater or whatever? Is that the question?
You will try for other antibiotics, or how you check that
how you stop the infection. Yeah, I'm not a medical doctor. I'm sorry. But of course, it's possible that you have to use effective other effective antibiotics in this particular patient case. But I'm not sure whether this was a question. Sorry, maybe you can discuss it.
Anyway, thank you very much, and let's give a big hand to.
Thank you very much, sir. We can discuss in the lunch period also, we can discuss this thing because time shortage is there. Quickly we have to move over. Dr. Sachidananda Dey, ICR National Professor, ICR India, Karnal, Haryana. He will be talking about multi-drug resistant Escherichia coli infection in dairy animals. Dr. Sachidananda Dey, please come over the dais. Dr. Sachidananda, please come. Sachidananda Dey completed BBSc from Vidhan Chandra Kishore Vishwavidyalaya, MBSc and PhD from IVRI, postdoc from Sweden and USA, more than 30 years of experience in molecular genetics of livestock and bacterial genomics. 2 technologies commercialized for commercial use, 3 Indian patent granted for him. More than 5 technologies are ready for commercial use. He is having 20 master students and 18 PhD students to supervise. He is a fellow of National Academy of Agricultural Science, National Academy of Veterinary Sciences, and National Academy of Dairy Sciences. He is having more than 180 number of international publications published. Dr. Sachidananda Dey will be talking about the multi-drug resistant Escherichia coli infection in dairy animals. Please.
Thank you, Dr. Shirota. Good afternoon, everyone. Dr. Chattopadhyay, Mandal sir, and Asinda, and our teachers, Malik sir, and of the dais, many scientists, and my fellow scientists. So I'll be restricting my talk especially on the E. coli because ESBL and E. coli they are difficult to treat. If you think earlier presentation also, he restricted mostly to the, again it is E. coli, ESBL, because gram-negative bacteria treatment is difficult. But treating a gram-positive bacteria, I think it is little better. Anyway, it depends on what kind of AMR genes are there. So next slide please. So again it is the same thing. We are all residing in the environment. It depends upon the environment, animal and human, our behavior, how we are behaving and how we are transmitting a bacteria from one place to other. Next. So the right side panel, it is showing some of these hypotheses, whatever we have written here. Pathogens cannot be created, that is the first thing. All bacteria or virus, nobody can create, right? So they can only multiply and transmit from one to other. Next one, they selectively multiplied, enriched in milk and other media. And my talk is restricted to the mastitis, being from their institute. So I will be restricting mostly mastitis causing bacteria, that E. coli. And resistance to antibiotic can be developed or acquired by genetic factor, either by vertical or horizontal transmission of genetic material. And genetic mechanism to overcome the resistance may exist before the discovery of antimicrobial. That means bacteria itself is having some kind of mechanism itself to protect the antibiotic, which is not even discovered till today. And animals are born healthy. Milk is the healthy citizen. All meat and everything, all this, whatever baby born, they are all selectively healthy, right? So don't think that milk is secreted along with bacteria. No. Only thing is that we are handling not properly or udder is not healthy. Next is contamination should be prevented. That is the main. Next. So I think we can go to next. So regarding this thing, we are concentrating on the mastitis, and these three bacteria seems to be more notorious. One is E. coli, another is Klebsiella, one more is Pseudomonas. These 3 bacteria seems to be the more notorious in this. Next. This is the next please. So these are the some of our publications. Come next one. So regarding my entire talk, I will be talking about some of these wet lab experiments, getting bacteria from the mastitis cases of 1,000, and at the end of it, 81,000 E. coli isolates, which is available globally. We thought that if we go for sequencing each and every isolates of the mastitis E. coli, it is very difficult.
maybe your money will not support you. So what we thought, let us have a selection of whatever sequence repository available in the internet, let us download it. We downloaded around more than 1.5 lakhs of sequences, and then we started with the same platform. Let us come to the same platform and then start analyzing it. So after screening many procedures, 81,000 of E. coli we could able to select to have a same platform to understand our data. Next. So this is the type of whole genome sequences we got from the 1,10,000, and out of that 81,000 and that is time period is 1905 to 2024, and these are unpublished data, some of these publications. And typically a E. coli, next slide please. This is our wet lab experiment. Next. What we do to get at the beginning of my work, I started giving some freelancer to the farmers. Farmers supporting a milk sample to our lab, we used to give the AST data next day morning, so that animal can be treated properly. Otherwise, nobody will bring milk to you until unless you give some kind of supporting to them. So milk sample, antibiotic sensitivity test within 12 hours, you give them the whatever antibiotic required for them. And then as an R&D research, we try to go for E. coli, Klebsiella, and Pseudomonas, and some Staphylococcus. This data is the old data. Anyway, the data is not important. Important is the what kind of strategy we are following to get the bacteria from the farmers. Otherwise, farmer will not come. Next. These are the different genes. Earlier presentation also you might have seen. So ESBL seems to be the notorious one, because this penicillin group and this cephalosporin group, they are the main antibiotic using nowadays. And next one is fluoroquinolone, again another group of antibiotic, and then carbapenem. These three are the major antibiotics available or treated rather not only in the animal, in human being also. Next. So this is the typical E. coli genome, the 5 MB. This is the major chromosome, and all the side-wise, cursor is not there, all they are the plasmid, they are the different plasmid. Smaller the plasmid, more notorious they are. They can able to move from one to other. And the next question is, whatever AMR genes are close to any transposable element or the mobile genetic element, if the AMR genes are in the smallest circle, they probably circulate from one bacteria to other very quickly. Next. These are the E. coli can be classified into two ways, either phylogeny or sequence type. They are the theoretical one. Those who are working in the E. coli, they can able to know that. This is not a rocket science, simply PCR or sequencing. Next. So MLST seems to be good for the bacterial typing, but in case of bacteria, we are going for sequence typing based on this MLST only. So all sequence type of E. coli, MLST only. These are the housekeeping gene. Based on the variation, you can classify them. Next. We could have it next. This is the movement of, this is a sequence type, that means MLST type of E. coli, how they are moving from one continent to the other. So this is the earlier speaker, some questions were raised, how the movement of the bacteria or the AMR genes are moving from one continent to other. This indicates US, Europe, many things are there, and you find India is not that much. That does not indicate that third world countries, somebody raised this question, whether third world countries, they are not having such kind of issues as well. Yes, we are having more issues in the AMR, but our data is not enriched. So this cycle and this thing are, this is not published work, this is published work. I got it from carbapenem resistance E. coli sequence type 131. So same thing in mastitis also, we got one ST131 is more prevalent, but not carbapenem, that is ESBL. This is ST131. Next. This is another notorious E. coli, ST167, and their movement. Again, this movement is same. And because again you see the India, the how is more stronger. Next. This is another point of ST410. So dissemination pattern of ST410. Sorry. So this is ST131. What does it mean by ST131? This is another one important E. coli with ESBL E. coli having this particular type, and they are having human infection of UTI infection, major UTI infection of ST131. And conjugation is the main horizontal gene transfer mechanism and responsible for mobilizing registration among the enterobacteria, not within the E. coli, but E. coli to Klebsiella, E. coli to Shigella, and other E. coli. And conjugation efficiency strongly correlates with the plasmid maintenance. Third one, horizontal gene transfer may be the important new to fight the antibiotic resistance. If we think that we are going to develop a new antibiotic, that is also no doubt, this is a good thing. But another thing is that can we stop the movement of conjugation from bacteria 1 to 3? This is the main critical question. Next. I think you can go to next. There all the types are there. Go to next. We type the whatever isolates we got from the wet lab, from mastitis lab in Karnal nearby region. They belongs to all ST131 and they are subsequent typing, and they are human pathogen of UTI infection. Next. So this is also how we can classify all E. coli mastitis pathogen based on their AMR, their right side, their AMR genes, how we can classify total E. coli isolates of that. This is a very important one. This is based on the, I think, 80,000 of the sequences we studied, and we found that out of these AMR genes, the CTXM15, the top one, seems to be very high. If we want to screen any kind of AMR gene, this one is more in E. coli bacteria, and this is more notorious and more important. And again, the same question in 19 and 20, the peak is high. That does not indicate that COVID period is having more bacteria. No. The question is, data is more, statistics is given more top. That is the question. Otherwise, bacteria remains same. If data is not that much, probably this peak height will not be there. Next. This is how 80,000 sequences. They are human sequence mostly, then environment, then animal, and then bird. Birds are moving from one continent to one place to other. So they are moving the bacteria from one place to other. And there are the different genes. If you see the resistance pattern genes, CTXM15 seems to be the ideal one. That means more amount of this transferring this ESBL factor is coming on this particular particular group. That's what we thought in our EA, that we have a cartoon on that. So whatever infection cattle is getting for the mastitis or human, they are from the environment only. Environment is the major reservoir of all pathogens. From there we are getting the contamination. Next. This is another cancer causing E. coli in bladder, urinary bladder. In UTI infection, sometimes you have a cancer in the urinary bladder, and some bacteria responsible for this, and we found in mastitis whether such genes are there or not. We found that not a single bacteria or mastitis of our wet lab, they are having such kind of cancer causing gene. But then we thought from where it coming, we tried to get some of the Delhi sewage water, and we found their bacteria are there located, and they are having such kind of genes. So little bit we can think that some milk samples are little bit safe. Next. So this is the particular gene, this is a theoretical interest. We started working how we can able to study the M type of CTX. Next. You will not go into this is a totally elaborated work. So we try to locate the region of the not the CTXM is an enzyme which can able to clip the beta-lactam ring. So if you see the entire gene, it's not that all genes, all portion is responsible for more polymorphism, more variation to clip the beta-lactam ring. It is some portion which is having more mutation, more polymorphism, so that they are very efficient in clipping the beta-lactam ring, responsible for the penicillin, cephalosporin, or carbapenem. Next. So they are the particular region we have marked. Next. So this is the in silico study, totally gene dynamics, how they are. Next, you may not be interested. And out of this ESBL, the CTXM, cefotaxime, this particular resistance is developed in Germany, Munich, in 1989. From that point of time, it seems to be spreading very fast globally in different continents, different countries. Next. This is the different classification of CTXM, theoretical interest. Those who are interested in this type of work, you are feel free to contact me. Totally analysis bioinformatics work. Next. They are the group. Out of this group, cyphaloxime AM group 1 seems to be the more notorious and more prevalent. Next. Next. This is our theoretical interest. We try to plot whatever CTXM E. coli available in Indian context, how they are located in different states. Next. So this is one important cartoon slide showing that how the left side it is showing the resistance mechanism, and the right side how the horizontal gene transfer is moving from one bacteria to other. Out of this transduction, conjugation seems to be the very important point of transferring from one bacteria to other. More smaller the size of the plasmid, they are more easily can be transferable from one to other. Phage maybe, but we do not know whether phage is really creating nuisance or not. We try to establish that CTXM in the red arrow indicate the CTXM gene sequence, and then right side and left side they are the insertion there, the kind of mobile genetic element, how mobile genetic element is helping to to transfer the resistance gene from one bacteria to another. We found the next slide. We found that this is the resistance gene, and right side, left side, they are the spacer. Less the size, smaller the closer the situation of any kind of mobile genetic element with the resistance gene, in very fast become more. And even this cassette is available in the plasmid. Easily they can able to move from one bacteria to other. Next. Next one. This is how this particular way, active sites of the beta-lactam gene is responsible for living, and why they are this much of polymorphism or variations in this particular region, not the rest of the genes. This is a theoretical interest, not those who are working in this area, they can discuss. Next slide, please. Next. Next. This is our abundance of different groups based on the how we can classify them based on the host range, based on their resistance genes, IS element, insertion sequences, that means transposable element. Next. Next. This one is very important one slide. This is insertion sequence 26, which is out of many insertion sequence and transposable element. IS26 seems to be the one notorious transposable element, which are all the center indicates and nearby genes are their resistance genes. IS element, if this IS26 is close to any AR genes, they can able to transfer from one bacteria to the other, more faster than the other. Next. Next, after this IS26 is ISBSA3. This is another IS element, which is second after this IS26. Next. This is again AR gene, how closely they are, similar pictorial presentation in different way. Now the question is, a lot of science is there. Now what is the mitigation? How we can solve it? Being animal science or being a human being also. So we try to, there are many ways of doing it, but this is one way we can do from animal science point of view. If we think udder as a external wound, probably first therapy seems to be ideal. We try to identify some of these parts out of our for our E. coli as well as Staph aureus. So next slide, please. So to get a fudge is difficult, but not impossible. You can take a sewage water is full of fudge. What we did, we got some of the bacteria, but we don't have any solution for that. We tried to search out the fudge. Then what we did, NDRI has this sewage treatment plant. We take the water from that. We got it. But some bacteria treatment is not available. We cannot get any fudge out of that. Then we get the sewage from this belly. To get this sludge from this some treatment plant is very difficult. Nobody is spare you anything because they are always aware of this. So how typically one of our students collected that one. And we found that whatever mastitis bacteria we got, difficult bacteria, solution is there in this fudge, in this sewage water. Anyway, that is how we are going to, this is the theoretical one, how we got this thing. Next slide, please. So these are the different type of fudge. Working with fudge is very difficult. You cannot store a fudge, you can store a bacteria, virus, but you cannot store a fudge. Fudge, to make the fudge alive, you have to make the host alive. So, but if you take host and fudge together, fudge will lyse the host. They will not allow the host to stay. So definitely it will have to be, we try to understand, get the many fudge, but we cannot able to store that. Next. They are the different plug size, how they look like. And we published a small one out of that, how to get this MRSA fudge. Very easy to get the MRSA fudge, but very difficult to get a gram-negative fudge. Because gram-negative one cell one is very difficult, and fudge will not going to enter so easily into this. But gram-positive bacteria very easy, because the peptide glycan, this numnac pentapeptide beta-glycine, they can easily kill by this endolysin. So this is E. coli fudge. Next one. So this is one fudge picture we got transmission electron microscopy. We found interesting, but once we sent for the sequencing, we got some difficult sequence result. We are not going to publish this one. This is another fudge of the we got from SVBBI. Practical application. Out of this lot of this theoretical work, we found what is the end product for the farmers. So some of these things, whatever earlier speaker also told. So you can go for PCR, it's very specific, timely, or you can go for real-time PCR, still it is faster. Maybe you can give result within 2 hours. But if you go for biosensor, antibody based, probably 15-20 minutes is enough. Next. So we got some publication out of that, but we are not happy to get to come into the farmers level. But we're trying for that. This is one media we developed. So that within 3-4 hours we can able to detect the type of ESBL we are having in the milk. Say for example, milk you are having milk sample. So if you add this particular sample into the media with blue color, probably the color change will indicate whether that particular an A or there. You don't need to give any incubator, simply put in room temperature, maybe 20 to 30 degrees is enough to multiply the bacteria, and based on that you can detect whatever it is there. Next. So this is a very simple media, maybe 10-20 rupees is required to see that. So it's not only that, even the tube, the sterile tube is the costly, media is not that costly. And color chromogenic substance is the damn cheap. Next. So we try to extrapolate that based on the color, can we see the amount of bacteria it is having. So we try to see the number of bacteria in 10-fold dimensions. Next. We found some antibacterial agent from the cannabis. Cannabis, you might be having cannabis is plant available everywhere. The cannabis extracts can able to resist the biofilm. See, mastitis, chronic mastitis is nothing but it's a biofilm in the udder. So if you some kind of extract can be given and the cannabis extract along with antibiotic, probably it will solve some issue. You don't have any understanding on that, but anybody is working, probably you can have a look on that. Next. The summary of the particular my talk is that mastitis is not a single infection, it is a mixed infection. Don't think that it is a Staphylococcus or E. coli, it's a mixed infection. Whatever they are getting from the environment, they are coming to that. And all mastitis pathogens, they are not intestinal, they are extra-intestinal, similar like your EPI infection in case of human being. And CTX-M seems to be the important one, and environmentally the major source to spread of this ESBL E. coli, and horizontal gene transfer conjugation seems to be the major concern. Transposable element, another, if it is close to that integron or transposable element, they are close to the AMR gene, probably they are the. So identification of a particular AMR gene is not that important. Along with that, try to identify the IS element and the integrons. The biological waste treatment seems to be the key point of treating this, to withstand this particular AMR issue. And treatment with proper antibiotic sensitivity, as my earlier speaker also told like this. So more quickly the kind of diagnosis, probably proper antibiotic is the pathogen, same thing I think there. The first therapy is this thing seems to be very promising for mastitis cases of molecular science. So issues in mastitis, environmental abundance, degree of virulence, and adhesion power or pathogen biofilm production, antibiotic resistance, and horizontal gene transfer. There are the several ways you can say how you can able to treat the bacteria. There are our hands. Whatever you can see our wet lab, some data also from the outside we took to make the story simple. So out of these all students, one girl is doing in silico and doing great work to understand the work next week. Thank you very much.
Yeah, thank you, Dr. Dev, for your very fascinating lecture. Yeah, one question. Yeah.
Yeah, very excellent, sir. So I got two questions, one from your first part of your talk and the second one, the second part.
Sure.
So I mean, from previous speaker, we have learned that there are, when you treat, use disinfectant, there is antibiotic resistance. So in your system, how that get transferred, because your is with the transfer of genes.
How they transfer from one bacteria to other?
Right. When you have antibiotic resistance, when you use disinfectant.
Yeah. Disinfectants is a non-specific one. They can kill any bacteria, maybe a non-pathogenic pathogen, right? But once you keep a pathogen, non-pathogen in an atmosphere like sewage or atmosphere, a healthy one will be getting this particular AMR resistance from the notorious one, right? Along with the conjugation. Because you cannot stop them in conjugation.
So when you use this infectant, then you get antibiotic resistance. Then how your system, how that antibiotic resistance will transfer?
No, disinfectants is a locally you can apply from topical one or some place, but you cannot use disinfectants in the sewage water atmosphere.
Okay, okay. Then the second question, because this, as far as I understand, the phases they are very specific.
Yeah.
So how you will use those phases to treat particular bacterium, and when you have mixed infection, so
No. Mixed infection cannot be treated by bacteriophage.
so in
You have to find out which particular bacteria is giving main notoriety. Say for example in ICU. In ICU, they are having in particular atmosphere in hospital or ICU, they are having a typical type of bacteria.
But in case of mastitis, you have mostly
No, mastitis is a difficult problem, a different problem from different area. From where atmosphere, what kind of bacteria is there, first to identify the host and then find out the phage from the sewage water or whatever is available with you. You must have a battery of phage to treat battery of pathogen. Don't think that one phage is able to solution for all. No. Is it clear? Is it? I'm okay.
no, I guess because you have mixed infection in mastitis.
Yeah.
So how will I mean?
Correct. Out of mixed infection, I am not saying that some are pathogen, some are notorious, some are difficult to treat. Out of that, only one bacteria will supersede. So if one bacteria is giving more dangerous with AMR, probably you kill that, not the healthy bacteria. E. coli is such an abundant bacteria in the atmosphere, human skin, human gut, animal gut, everywhere. If you find the E. coli in Google, this is the highest amount of pathogen, highest amount of genus, this particular genus available everywhere. Not only in the atmosphere, it is in the human skin, human gut, animal gut, everywhere. So you have to find out the E. coli. Even there some are E. coli are healthy, you know. This will help us in your gut. So don't kill that one. Only find out the AMR bacteria of E. coli and treat them with phage or whatever way you like.
Today, I'm very thankful to the talk and the topic you chosen for our course presentation. I have a specific question. How you can correlate your work with CRISPR-Cas technology? Because spatial is the main culprit for resistance and the bacteria.
Very nice question, my dear friend. He is my colleague, he is my batchmate. We are a very good friend. So CRISPR I explored in 2016. So I found that CRISPR seems to be able to break anywhere. But the problem with CRISPR is that if you use CRISPR can able to click whatever gene region I told, IS element and CTXN, they can cleave you. But the question is, CRISPR unable to find a ESBL bacteria and enter into this. Until unless this bacteria with you, then only you can do it in lab, but not in the atmosphere, where they are playing with nuisance. They are moving from one bacteria to the other. You cannot place a CRISPR in the soil, in the atmosphere, but you can play with CRISPR with a confined laboratory bacteria you are handling, or you are handling a zygote. You can do that. CRISPR is the place for the proper place, but not CRISPR is the place for bacteria available in the sewage water or in the atmosphere. Probably it is expensive. Or you can play a phage with CRISPR to kill the ESBL to find out, but they cannot search it. Human being can search a bacteria, but phage cannot search. It's a chance factor.
Can you make a phage for a specific?
Phage can be created by non-specific, whatever the earlier question asked. No? You can prepare a kind of phage which can able to solve this issue for all hosts, but it is really difficult. Phage is such a specific, that is why the bacterial phage typing is known. That means a phage is very specific for a bacteria. You cannot make a phage which can able to kill all bacteria. Thank you.
Just I want to curious about the viral vector can be used if there is some kind of AMR specific ligands, and that part if you introduce in the viral vector, non-pathogenic viral vector, like a different part. This is number one. Can you give some suggestion? Number two, whether we can able to do some kind of peptide or small molecules to interact on this part.
So I got it.
Phase on that part.
Yes.
Because so this decision, there is a common things are there, definitely. And we have to find out, make the small molecules therapy over there.
Sure. Thank you, Shankar. He is my batchmate of BBBSc. So I think the first question regarding this viral vector, viral vectors are very known for their specific transcription efficiency, 100% efficiency for delivering a gene from one place to other, right, a particular area. Now, if you are using viral vector in this, again, the same question like this one, we have to search it. Which bacteria I should enter? If you are using viral vector in a confined laboratory, it is good. If you are giving a viral vector to a atmospheric solution or swage, no, they cannot find it. They will be lost somewhere or diluted somewhere and expensive. Preparing viral vector for treating a but if prepare a viral vector for a particular host, many people like to start to
I request now Professor. Now I request Dr. Sajinandan, please. Now I request Professor Sitanshu Mohan Dev, please come on the dais. He is National Professor of ICAR, to hand over the memento to the chairpersons and report here. One by one we have to hand over the memento, the token of love and gratitude to our chairpersons. Dr. Ashwin Kumar Pal, Professor Punendra Biswas.